check. Hey, 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 check. 1, 2. Hey, hey, check. Hey, test. 1, 2. Hey, hey, check. Check. Hey, hey, hey. Check. Hey.
Good morning. We are pleased to inform our guests and participants that our program will commence shortly.
Good morning, everyone. Please stand for the invocation and please remain standing for the singing of the Philippine National Anthem.
In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Our most gracious Heavenly Father, we come to you today to praise and worship you and give you thanks for all the things you continue to provide for ourselves and our families. Father, we humbly ask for forgiveness for all the times we have offended you. Continue to guide and protect us, Lord. Bestow upon us your unending grace and healing, that we may in turn become instruments of gentleness and compassion to others. We ask all this in the name of your Son, our Lord Jesus Christ, with prayer and intercession of the Blessed Mother.
بسم الله الرحمن الرحيم. اللهم إياك نعبد وإياك نستعين. اللهم اهدنا الصراط المستقيم. اللهم وحد صفوفنا بين المسلمين والنصارى واللوماد إلى صراطك المستقيم. اللهم امنحهم العيش بالأمن والسلامة والتنمية المستدامة في مدينة دافاو. اللهم لا تزغ قلوبنا بعد إذ هديتنا وهب لنا من لدنك رحمة إنك أنت الوهاب. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار والحمد لله رب العالمين.
Amoy nen manama kami gimot tolangon, manotod kakaroson no. Si koikaw kami dokul tolangon, way migtumpi to tano. Si koikaw kami bohoy to kopianan tolangon na maoto. Pusako ka no pag-ugpo, way kasabo kakoy oyot kalambo. Kay kuro tamana kakodin panubado ay pag-ampo, kaupianan igboy no, way kakoy kong ingono, way kalaan ka lang.
You may now take your seats. Thank you. Mabuhay og madayaw! Ladies and gentlemen, our esteemed guests, partners, and project staff participants who are present today for the third program-wide Congress of the Philippine SkAI Artificial Intelligence Program. I am Jonah.
And my name is Renz, and it's with great honor that we serve as your host for today's event.
Yes, as we prepare to start our program, Renz, we would like to take a moment to recognize the distinguished guests and partners from various agencies who are present with us today. We invite our guests to please rise when introduced so we can give you the recognition that you deserve.
The program leader of the Philippine SkAI Artificial Intelligence Program and the project leader of ALAM LSI, Dr. Jose Ildefonso U. Rubrico.
the Director of the Department of Science and Technology, Advanced Science and Technology Institute, Dr. Franz A. De Leon.
The DOST Philippine Council for Industry, Energy and Emerging Technology Research and Development, Technology Development Division, represented by SkAI-Pinas project managers Ms. May Rose B. Perinas and Engineer Bianca Marie B. Domingo.
Our esteemed guest from the Philippine Space Agency, the Director of Space Information Infrastructure Bureau, Dr. Ariel C. Blanco.
Associate Professor at the University of the Philippines National Institute of Physics, Dr. Reynabel C. Reyes.
Professor at De La Salle University and a DOST shared AI board member, Dr. Arnolfo P. Azcaraga.
ERDT Project Leader, Associate Dean for Research, and a professor at the College of Engineering at the University of the Philippines, Diliman, Dr. Ruel M. Ocampo.
Chief of the Computer Software Division at the Advanced Science and Technology Institute, Ma'am Joanna G. Sihuko.
Assistant Secretary for Development Cooperation, ASEC Rodolfo J. Calzado Jr.
Division Chief of Solutions and Services Engineering Division, Engineer Alvin E. Retamar.
We are also honored to have notable guests joining us from DOST Region 11.
Mindanao Development Authority.
Let us also give a heartfelt round of applause to our partners from the Academe who are also here, specifically representatives from University of the Philippines, Mindanao,
Philippine Science High School, Southern Mindanao Campus,
and University of Southeastern Philippines.
and to our Facebook Live audience, thank you for being part of our live broadcast today.
Thank you all for helping us in ensuring a warm welcome for our respected guests at today's gathering.
Yes, we're so glad to have you with us during our third program, Congress. Since building on the success of our first two Congresses, significant strides have been made in promoting artificial intelligence research and development initiatives that empower Filipino communities and positively impact various facets of lives for Filipinos.
The SkAI-Pinas Program-wide Congress, now in its third iteration, successfully exhibits notable advancements in AI research and development while also promoting cooperation across multiple sectors.
Without any further ado, at this moment, to formally begin our program, it would be my honor to introduce the first Balik scientist of the DOST Advanced Science and Technology Institute, spearheading research in AI and robotics in 2017 to 2018. He obtained his bachelor and master's degree in electrical engineering from the University of the Philippines, Diliman, and his PhD from the University of Tokyo, where he later returned as a visiting researcher and assistant professor. He had worked in the energy industry and was a faculty member at UP Diliman. In 2018 to 2023, he served as a full-time professor at UP Mindanao. Currently, he leads two R&D initiatives in artificial intelligence and AI robotics, the SkAI-Pinas and Asimov programs. Please join me in welcoming the person behind this project, SkAI-Pinas Program Leader, Dr. Jose Ildefonso U. Rubrico.
Good morning, mayong buntag, magandang umaga. So I usually limit my welcome message to 5 minutes. But since this is the culminating Congress, pagpasensyahan nyo na, gumawa lang akong outline, wala pang speech talaga to. So gagawa pa tayo ng speech ngayon. Director Franz De Leon, Director of ASTI, ASEC Calzado Jr. Of DOST, Director Blanco of the Philippine Space Agency, Dr. Ascaraga, my fellow shared AI board member, Dr. Ocampo, a long-time ally, mentor from UP Tripoli, Asti Alam, who came all the way from Quezon City to join this Congress with Ms. Joanne, Engineering, who's also joined us today, Alam LSI team, who has been really working hard, okay, to make this possible, along with the Asti Alam team, of course. Other honored guests, Ms. Mitch Lopez from UP Mindanao, who has also been a long-time ally of the and supporter of the program. Guests from the different agencies and institutions. Welcome to the third and culminating Congress of SkAI-Pinas. SkAI-Pinas. All right. So what is SkAI-Pinas? SkAI-Pinas is essentially a program that tries to develop mechanisms towards operationalizing AI at scale for our country's big data. So medyo medyo dense. Sige. Essentially yung SkAI-Pinas, ang gusto nating ma-achieve is gagamit tayo ng AI para yung mga kailangang gawin, for example, sa remote sensing na workflow at sa iba pang mga workflow, mapapabilis natin at mapapadali. And yung ginawa namin at makikita nyo mamaya ay meron kaming mga mechanisms, essentially mga datasets. For those familiar with AI, kailangan natin ng datasets, kailangan din natin ng models, tsaka kailangan natin ng lugar kung saan sila matatagpuan. So yun yung i-deliver namin at dinideliver namin ngayon, both yung team dito sa Davao tsaka yung sa Quezon City. Okay. So it is the flagship AI program of the DOST, and at the time it enjoyed perhaps the largest funding. I'm aware that there are gonna be more now, since AI has really become well known now. There's gonna be coming more and more these kinds of projects, and yeah. So saan ba nagsimula to? Nagsimula siya a long time ago, relatively long time ago, in 2017 and 2018 as a balik scientist, a small balik scientist project sa ASTI, yung tawag ALAM. Okay, so ASTI labeling machine, automated labeling machine, doon talaga siya nagsimula. And ang pasimuno, ang reason is, ang daming satellite imagery ng ASTI na nakukuha. Kaso, ang bagal, kung manual yung pag-label natin, para magamit ang bagal. So, nakita namin yung opportunity na gumamit ng AI para mapabilis yung pag-label, pag-identify. So, doon talaga nagsimula yung SkAI-Pinas from that ALAM project. And some of the original researchers are here. Si Elmer, si Jeff, then they were under Ms. Joanne then at that time, no? Sa CSD. Iba pa yung director nun, si Dr. Marciano, who is now the Director General of the PhilSA, Philippine Space Agency, and then continued on dito sa SkAI-Pinas with Dr. De Leon. All right. So, if you think about it, nagsimula siya nung ang AI parang hindi pa kilala talaga sa Pilipinas, di ba? 2017, 2018, pag sinabi mong, Sir, Ma'am, gamitan natin ng AI, parang sabihin nila, bakit? Kasi meron naman silang mga algorithms, di ba? Na hindi nila kilala pa yung AI. But compare that to now, almost a decade later, AI has become the cool thing, di ba? Siya yung bandwagon ngayon na everybody wants to join. Right? So, we would like to show later kung ano yung nagawa over the years. So, medyo mahaba-haba yung proseso ng paggagawa niya ng program. Okay, I think that took around 2 to 3 years mainly because medyo mahaba yung pag-propose and then yung sa pandemic. Naabutan kami ng pandemic. So, nagsimula siyang i-propose, I think 2019, pero na-implement siya 2021 dahil coming out of the pandemic. All right? And then, yes, it has been a long and story-filled adventure and journey. So before I go to the key outputs, siguro this is the time where I will thank certain parties and people, okay, without whom siguro yung program hindi na nakatawid dito sa final year of implementation niya. So merong mga nangyari, of course, administratively, etc., which I will not go into. But first, I'd like to acknowledge yung PSHERD because they, with me and my team, really fought it out para mapatuloy yung program. So ito, sila Miss Yami, si Engineer Bianca, si Miss Edna, Miss Claire, of course, si Dr. Paringit, who is the director of PSHERD. Sila yung funding agency and also before si DOST under Yusek Guevara and Secretary De La Peña, and now under Secretary Sulidum and Yusik Lea. Okay. So, and then of course, ASTI, all right, Director Franz. In continuing this journey, ASTI, who has been really part of this program from the start, has really taken a sort of a very important role in the final year of implementation. Of course, the CSD, okay, under Ms. Joanne and team leads. So, kumbaga, sabi nga ng Beatles, diba, we get by with a little help from our friends. All right. So, also, the SkAI-Alam team, or the SkAI-Alam team, who has also been with us throughout the years, sumabay talaga sila sa amin. So, we are very thankful for that. And the team itself, yung Alam LSI. So, kwento lang, nawalan yan sila ng trabaho ng 6 na buwan. Kalahating taon. Okay? Mahaba-haba yun. Pero at the end of the day, nung nag-restart na yung program, nandyan pa rin sila. So palakpakan po natin sila. So this is no small feat and I really appreciate how they shared the vision. Enough that they would do that kind of personal sacrifice. So they asked the Alam LSI team and to all, si Mamich din actually sa UP Min. All right. And to all those who have helped us, who are now unnamed, but who know who they are, maraming salamat. All right. So later on, makikita nyo yung key outputs ng SkAI-Pinas, Alam LSI, and of course, si ASTI Alam. And we will show in a video presentation and maybe sa panel discussion, then pwede mapag-usapan kung anong meron na pwedeng magamit ng different agencies pag nagkataon. Right? So this includes datasets. So ang datasets po natin, nasa millions na po tayo of samples. Okay? So if you're familiar with deep learning and AI in general, how it is implemented now, the more data you have, the better. Di ba? All right. So we have around millions of that. We have hundreds of models, and we are able to identify hundreds of different types of features. For example, volcanoes, sugarcane, banana, coconut, yung mga ganon. All right. And then, aside from that, we also have a portal Okay, both si Alam LSI and Asti Alam, we have a portal where you can access, para siyang gateway to access all of these objects that are useful for AI, for the AI workflow. So, okay. So, now, let us proceed with the rest of the program and look forward to brighter days ahead. If I may borrow a line from Joseph the Dreamer. Okay. When God closes a door, He opens a window. Daghang salamat o maayong buntag usap.
Thank you, Dr. Rubrico, for your inspiring words and your overview of the SkAI-Pinas project, which showcases your dedication and passion about the project. Now, to also deliver a message, let me introduce our next speaker. He is the director of the Advanced Science and Technology Institute of the Department of Science and Technology, and concurrently a professor of electronics engineering at the University of the Philippines, Diliman. He assumed the position as the director of the USC-ASTI on April 15, 2021. He attained his BS Electronics and Communications Engineering and MS Electrical Engineering in UP Diliman in 2003 and 2005 respectively. He later obtained his PhD in Electronic and Electrical Engineering at the University of Southampton at the United Kingdom in 2014. His research interests includes digital signal processing for audio and communications, music information retrieval, audio engineering, and adaptive filters and linear arrays. He has over 18 years of teaching experience in his alma mater, UP Diliman, under the Electrical and Electronics Engineering Institute, where he teaches signals and systems, digital signal processing, and digital audio signal processing, among other things. He has received a number of accolades as a faculty researcher and has led various R&D projects from the OST and UP Diliman. He was a visiting researcher at the Chulalongkorn University in Thailand and a fellow researcher at the Kyushu Institute of Technology in Japan. He served as interim chair of the Asia Open Run Academy from the 29th of June 2022 to 24th of April 2023. Please give a warm welcome, Director Franz A. De Leon.
Magandang umaga po sa lahat. Of course, Doc Joe Rubrico, Doc Ariel Blanco, Doc Arnie Ascaraga, Sir Roel Ocampo, DOST Assistant Secretary Rod Calzado Jr., my colleagues at DOST, ladies and gentlemen, a pleasant morning to all of you. So it's an honor to be here with you all as we celebrate our collective progress in making AI more accessible, impactful, and sustainable for Filipinos. When we first imagined leveling the playing field for artificial intelligence adoption in the Philippines, we actually pictured a world where Filipino researchers, government agencies, and even startups could turn their innovative ideas into real-world applications. So actually, nakwento na rin naman ni Doc Joe kanina, nung panahon na yun, yung pinaka-obvious na starting point, ano? So actually, Earth observation. So Earth observation data back then seemed like the perfect starting point. So whether it's mapping flood risks, monitoring crop health, or outlining building footprints. So ASTI has been privileged to support our country's venture into space and collaboration with academic and international partners. And of course, we are happy na lahat ng iyon na ipagpapatuloy na with the Philippine Space Agency. Now, for us at ASTI, that experience remains foundational to the AI-driven work we do now. So in fact, pinagpapatuloy siya through our current projects and programs. Now, early on, we realized that Filipino AI researchers, engineers, and enthusiasts often faced hurdles in AI development. So, very aware yung mga researchers dito. So, some lack the computing power to train complex machine learning models. Others struggled with labor-intensive data labeling. Ito usually inaayawan na trabaho ng part ng AI, yung pag-label. And many simply weren't sure which best practices to follow for successful deployment. The SkAI-Pinas program, including the ASTI automated labeling machine and the ALAM large-scale initiative, was born out of this very need to streamline the development of AI-powered applications for our stakeholders. So by leveraging Earth observation data, among others, and providing tools for data pre-processing and advanced model optimization, SkAI-Pinas seeks to empower Filipino innovators with the necessary resources and expertise to develop, deploy, and refine AI solutions. So over the past 3 years, we collaborated closely with government agencies and research institutions to build AI models targeting their immediate pain points. While the tailored solutions addressed urgent needs, we soon realized that a purely ad hoc approach to AI development wouldn't be enough to keep pace with the rapid evolution of AI. So the AI landscape changes too quickly for any single model or even a handful of experts to keep up with the current demand. So what truly mattered was building an ecosystem where Filipinos could learn, adapt, and keep innovating without being hindered by resource constraints or knowledge gaps. With ALAM LSI focusing on data pre-processing and initial model training, and then ASTI ALAM our end handling optimization and hyperparameter tuning, we're turning AI development into a collaborative effort. So soon, we'll make these pre-trained models available through our Democratized Intelligent Model Exchange Repository, DIMER. In short, meron kaming model store na magiging public-facing, ensuring that anyone can confidently build and refine AI solutions. Our mission is to cultivate an environment that not only accelerates AI development, but also empowers our own stakeholders and end users to adapt and thrive alongside the technology. So today's Congress is a testament to the power of shared vision, collaboration, and continuous learning. Each story you'll hear sa mga talks na maririnig natin for this morning underscores the collective passion we share for AI to uplift communities and strengthen our nation. So I invite each of you to please engage wholeheartedly, learn from our experts, connect with them, and let us drive the Philippine AI space forwards. So before I end this talk, I sincerely would like to thank Doc Joe Rubrico kasi maganda yung kwento niya. So, sinimulan niya as a balik scientist, nagsimula maliit, pero look at where we are now. Baka hindi na lang niya nare-realize, pero malayo na yung naabot natin. Opo. Imagine from a small-time project, this is actually a flagship project for AI. Magkano to? Almost 300 nga yata to. So one of the biggest projects ng DOST for AI. So we look forward to more projects and collaborations with everyone, of course. And ito, unahan ko na, baka hindi alam na karamihan, welcome Doc Joe to ASTI soon. Yun ang masasabi ko. Thank you so much.
Thank you so much, Director De Leon, for your heartfelt message of support and dedication to advancing AI initiatives. As another program segment, we are pleased to present a video message from our featured speaker. To introduce, he is currently the Executive Director of the Philippine Council for Industry, Energy, and Emerging Technology Research and Development of the Department of Science and Technology, a position he held since December 2018. He holds a bachelor's degree in geodetic engineering, a master's in remote sensing, both from the University of the Philippines, and obtained his Doctor of Engineering from the Tokyo Institute of Technology. He is seconded to DOST by UP Diliman, where he has been Professor of Geodetic Engineering since 2014. He has served as Chair and Director of the Department of Geodetic Engineering and Director of the Training Center for Applied Geodesy and Photogrammetry. His specialization is in the field of remote sensing and modeling of hydrological and coastal environments for applications in disaster risk reduction and energy resource assessment. Dr. Eric, as he is fondly called, has conducted and led numerous research including the Disaster Risk Exposure and Assessment for Mitigation and Field LiDAR 1 programs from 2011 to 2018, which uses laser mapping technology to identify flood-prone areas throughout the country. At Pishired, he pursued innovations in the R&D grant program management, capacity building, and partnerships to accelerate the pace of technology and development and innovation in the Philippines. Ladies and gentlemen, you may now turn your attention to the screen for Dr. Enrico C. Paringit.
Maayong buntag sa tanan. We have the Department of Science and Technology, Philippine Council for Industry, Energy and Emerging Technology Research and Development are delighted to be part of the third and culminating program-wide Congress of the Philippine SkAI Artificial Intelligence Program, or SkAI-Pinas. This event is not just a culmination of a research endeavor, but also the continuation of a vision, one that harnesses artificial intelligence or AI to transform how we understand and utilize big data for the nation's progress. Despite the difficult challenges encountered, especially the change in the implementing agency of one of its two component projects, the team has demonstrated remarkable resilience and commitment. Their unwavering dedication has allowed them to overcome obstacles and rise to the occasion, ensuring the successful completion of this initiative. Please give yourself a pat on the back. You have earned it. Though the collaborative efforts of the ALAM LSI and the ASTI ALAM components, we have seen how AI can be leveraged to bridge the gap between data, abundance, and practical applications. The development of deep learning models, machine learning workflows, and the democratization of AI-driven remote sensing technologies are critical steps in ensuring that innovation serves the needs of our communities. The progress made in land classification, traffic management, disaster resilience, and even agriculture underscores the immense potential of these technologies to create meaningful impact. At the UST Pishired, we recognize that AI is an enabler of solutions. The success of SkAI-Pinas proves that when research, data, and computational power converge, we generate insights that drive smarter decision-making, more resilient infrastructure, and more efficient resource management. Through our funding and support, we ensure that initiatives like these do not remain as pilot projects, but grow into sustainable, widely adopted technologies. The strides we have made in AI applications and its ability to provide AI-enabled solutions across different domains demonstrate that the Philippines is not merely keeping up with the technological advancements. We are shaping them. The publication of multiple research papers, the training of specialists, and the development of repositories for neural network models all point to a future where AI is not just a privilege of a few, but a resource for the many. The success of this program would not have been possible without the steadfast commitment of our partners, the UST ASTI, the implementing agency, the dedicated scientists and researchers who have contributed their knowledge and expertise, and the stakeholders who are with us today. Your efforts have set a precedent for how AI can be harnessed to address national challenges, and we at the UST Pishired remain steadfast in our commitment to supporting initiatives that drive technological advancements for the benefit of our people. As we move forward, the challenge is to ensure that these innovations translate into long-term benefits for our industries, local governments, and communities. This entails fortifying alliances, honing our approaches to technology implementation, and consistently enhancing the availability of AI-powered products. It also entails encouraging the development of ethical AI, which places a high value on security, inclusivity, and responsible use. Let this Congress serve as a reminder that science and technology can improve lives and move our country closer for a more intelligent, data-driven future, provided they are directed by a common goal. After this meeting, we expect that the ethical and governance aspects of AI will have a clearer meaning. Congratulations to the entire SkAI-Pinas team on this momentous occasion. Let us continue to push boundaries of what is possible, and ensure that AI truly serves the Filipino people. Maraming salamat at mabuhay tayong lahat.
Thank you, Dr. Paringit, for your inspiring video presentation and sharing your insightful and inspiring thoughts with us. At this moment, we now invite you to again shift your attention to the screen, where a video presentation will showcase the current project status and highlights of Alam LSI and ASTI Alam.
Access to high-quality AI models is key to innovation, yet many researchers face barriers in obtaining them. DIMER, the Democratized Intelligent Model Exchange Repository, bridges this gap by providing a seamless platform for sharing, accessing, and deploying our optimized AI models.
The platform features models useful in traffic vehicle detection, building delineation, and landslide change detection, among others. These AI models are tailored to address the country's specific needs and challenges in disaster risk management, building smart cities solutions, and optimizing agricultural production. By utilizing computer vision, the AI-assisted vehicle classification and counting model helps manage traffic flow and identify congestion points using CCTV footage, contributing to better urban planning and smart city solutions. The AI model classifies vehicle types and counts them, providing valuable insights for road safety and efficiency. Users can upload video footage to the platform, and the AI model analyzes it to classify vehicles by type, such as cars, trucks, or motorcycles, and count them accurately. The results are displayed, providing feedback on traffic density, allowing decision makers to identify areas of congestion and plan interventions to ease traffic flow, enhance road safety, and optimize urban mobility. Building delineation using AI is a key tool for urban planning and infrastructure management. By analyzing satellite images, this AI model precisely identifies and outlines building structures, providing accurate boundaries crucial for city planning, smart city initiatives, and infrastructure monitoring. Users can upload a satellite image to the DIMER platform, where the building delineation model processes it to extract detailed outlines of buildings. The resulting visual data provides insights that support efficient land use planning, urban development projects, and infrastructure assessment, helping decision makers create more sustainable and well-planned urban environments. AI is a powerful tool for disaster risk management, especially in monitoring landslide-prone areas using satellite and aerial imagery. This approach helps assess landslide susceptibility by identifying changes in terrain over time, providing essential data for planning mitigation measures. The model offers valuable insights for early warning and disaster response efforts, ultimately supporting effective planning and community safety. Users can upload satellite imagery to the DIMER platform, where the landslide change detection model processes the data to identify terrain changes that signify landslide impacts. This AI model helps decision makers assess damage, plan mitigation strategies, enhance community safety, and support effective recovery efforts, ultimately protecting lives and infrastructure.
From the very beginning, we've understood that meaningful AI innovation is about more than just technology. It's about collaboration. That's why we actively engage with the academe, government, and industry to ensure our AI solutions address real-world needs. By working closely with domain experts and solution developers, we gather critical insights and validation, making sure our AI R&D projects are practical, relevant, and truly beneficial to the communities they serve. Through these partnerships, we tailor AI applications to specific challenges, empowering organizations to develop their own use cases, leverage complex data, and make more informed decisions with unprecedented accuracy. Our goal is to democratize AI, making these tools accessible, ethical, and impactful, driving inclusive growth and technological advancement across various sectors. As we move forward, we invite you to join us in shaping a future where AI is not just a buzzword, but a catalyst for positive change. Whether you're a researcher, policymaker, or industry leader, there's a place for you in this collaborative ecosystem. Together, let's harness AI to solve pressing challenges, uplift communities, and accelerate the Philippines toward a more innovative, resilient future.
And that's the latest from Alam LSI and ST Alam. Thank you very much for the informative videos.
Now that we've covered the project status, we'll move on to the plenary session showcasing presentations by leading experts who will share their valuable perspectives and expertise.
That's right, friends, and it is my pleasure to introduce our distinguished speaker. He is a renowned expert in geospatial technologies and environmental informatics. He holds a Bachelor of Science in Geodetic Engineering from the University of the Philippines, Diliman, a Master of Applied Science in Geographic Information Systems from the University of Melbourne, Australia, and a Doctor of Engineering in Environmental Informatics from the Tokyo Institute of Technology in Japan. He successfully led and completed various R&D projects utilizing geospatial technologies in various applications, including environmental and agricultural. He is seconded to the Philippine Space Agency as the Director of the Space Information Infrastructure Bureau, wherein the SIIB manages infrastructures, including ground stations and high-performance computing facilities, and develops methodologies, systems, and tools to realize the space data value chain. Currently, he is a professor of geodetic engineering at the University of the Philippines, Diliman. To present his talk titled Space Data, Mobilization, and AI, please help me welcome Dr. Ariel C. Blanco.
Thank you very much, DOST, and thank you very much, Sir Joe Rubrico, for inviting the Philippine Space Agency. Actually, Sir Joe was my teacher in one of the electrical engineering subjects. So my talk will focus on space data mobilization, what we do to help other government agencies as well as local government units and other organizations, of course with the use of AI, machine learning, and other things now. So as an introduction, so the Philippine Space Agency was established in August 8, 2019, by the Philippine Space Act. So we are the central government agency in the Philippines addressing all national issues related to space science and technology applications. And we work on different key development areas. In particular, my bureau works on hazard management and climate studies, in part the national security and development, as well as doing some R&D and participating in capacity building as part of the Space Education and Awareness KDA. So in the Philippine Space Agency, we subscribe to this framework. Primarily, all of the things that we do at the Philippine Space Agency, or PhilSA, are mapped in this space data value chain. For this particular talk, we will focus on the capacity to analyze and generate insights from the data, mainly to generate information from data sets, primarily the satellite images. And we can see that supporting the value chain includes also the education capacity building as well as R&D. So if you look at this information extraction from remote sensing, I've been teaching remote sensing for a number of years. We can see that there are a number of processes that we do. We can extract schematic data, we can extract statistics, we can extract quantifications or physical quantities. For this talk, we will focus on classification, we will focus on extraction of quantities, estimation of, say, for example, temperature or bathymetry, and of course, also identification of specific features. Many of these would use simple, for example, simple algorithm or simple classification methods. And I was happy to see the video of the project wherein you have developed advanced technologies which we would like to utilize in order to better serve our, stakeholders. This is an example of a land cover map, which we utilize, for example, Sentinel data and Landsat, harmonized, meaning to say we are using different satellite images from different sensors, and we have to harmonize them in order to ensure comparability and application of the same method would work for different satellite images. In this case, we are trying to have more detailed land cover classes. Here, normally, if you look at the numerical land cover maps, you will see built-up areas. Here you can see mixed urban, you can also see dense urban fabrics. Basically, we are attempting to harmonize and even put more details into the built-up environment. This would also contain key agricultural crops, particularly dominant agricultural crops, including rice fields. So these are validated through field activities. We also do field activities. We go to places, and we collaborate with local government units in order to densify those training and validation areas. Okay. And in one particular project funded by the DOST, I am for Manila Bay, which I headed, we also did some comparison of changes. But now we are also looking at what drives these changes. And AI can also mine those drivers of changes instead of, say, doing some comparisons and extrapolating and doing some discussions on the possible drivers of changes. It can also be done using AI technology. We are also doing quantifications of different parameters in relation to forest. So for example, this is percent tree cover of Palawan. The algorithm can be applied to the entire country. But this was developed with the use of LiDAR data generated during the Field LiDAR 2 Practicals program, the Forest Resource Extraction Survey, which was headed by Dr. Paning in that particular project, and Sentinel-2. And we did some modeling in order to estimate the percent tree cover from Sentinel-2 at the resolution of 10 meters. So PhilSci is utilizing this particular algorithm to produce this type of maps. We also have estimations of tree canopy heights. We can see that in order to estimate certain parameters, one particular data may not be enough, so we have to consider different combinations of data. In this particular data, we use NASA's JEDI full waveform LiDAR. It's a LiDAR system on board the ISS, which can measure not only the canopy height, but also the full waveform representing even the structure and density of the vegetation over different areas now. And it gathers data across strips, so we can also correlate that and create a model with Sentinel-2 LiDAR, multispectral imagery in order to generate such products like tree canopy height now. We can say that, of course, this one would need validation. We can validate it by comparing it with NDSM from NAMRIA or even data coming from the Forest Management Bureau of the Department of Environment and Natural Resources. I was also glad to see that you are also mapping banana, but this is banana from Sentinel-2. And this is just an initial attempt of one of the staff of PhilSci in order to map banana in particular, utilizing different combinations of data from radar and optical imagery. But apparently based on the results, so you only need, for example, the S2 bands and also the principal components from the Sentinel data in order to generate a good classification of banana plantations. And this can be applied for, say, the entire Mindanao. This is an example of different algorithms, output, the CART, SVM, and RF, showing the differences and the degree of misclassifications in relation to field data or to actual data on the ground. And recently, we had some requests from VA Region 12, together with the Waste for Good. Waste for Good is an NGO, and they are helping the different farmers. And in this case, we utilize principal components analysis. And this is a depiction of the color composite of principal components 1, 2, and 3. And then we can clearly see that the green areas correspond to the annual crops. That means including, for example, rice and other smaller crops. But the red areas in this particular area, on the left side, represents permanent crops, which can be coconut, it can also be banana. So it should be subjected to another further, say, step. So this one is for. So now we can separate, for example, banana from non-banana using Sentinel-1, Sentinel-2, and the principal components of Sentinel-2, and plus enhanced vegetation index. In this particular example, there was a finding that inclusion of Sentinel-1 would improve the process of mapping banana plantations in certain localities. But agriculture in the Philippines is heavily impacted by diseases. I'm aware that there are also research from ASTI, especially the drone that roams around on the ground and then takes picture of the images from the bottom, from the ground. So this is, since we are space agency, we are looking at more on the satellite imagery. This is Sentinel-2 false color composites, where we can see different types of redness. Like brightness would mean healthy, typically, and different types of infestation or infested plants would translate into, say, darkening. And we can see that in the spectral signature, which represents the amount of reflected energy over different wavelengths, we can see the significant decrease in the reflectance in the near-infrared region. But if you have Fusarium wilt disease, you also have significant increase in the reflectance in the visible part of the spectrum. So we utilize this type of observations as well as spectral measurements on the ground in order to create maybe new indices that can help in mapping particular infestations of diseases as well as their severity. So this is an index I developed using the formulation of triangular vegetation index at the NIR, and then we also have a version for the what do you call that, the visible part. And the areas here that are typically showing reddish or orange colors, those are areas potentially impacted by the Fusarium wilt disease. No? But taking images or doing remote sensing of Fusarium wilt disease can only detect maybe moderate to severe. No? Because normally if you have slight infestation, it will not be visible in this type of resolution. And even in the infestation, impacted leaves are usually at the bottom part of the canopy. No? This is being validated in partnership with Tulunan LGU, as well as the DABPI and the Waste for Good startup company. And this is a post from the Waste for Good, indicating that the BPSS or Bayanihan para sa Sagingan is ongoing, and then there are validations, the taggings of different severities of diseases, tagging of banana versus non-banana, in order to further improve the product. No? And at the Philippine Space Agency, we are dealing with many things related to agriculture, not only the crop identification or the extent mapping, but also looking at the crop growth monitoring, crop health, damage mapping, and yield estimation. And currently, there is also a World Bank project with DA, and we are also assisting such collaboration with the Department of Agriculture. Now we go to mangroves. No? Mangroves is my favorite part because I also led a project on blue carbon funded by Fisher many years ago. And we have completed the mangrove map extent of the entire Philippines in 2023 in partnership with the Department of Environment and Natural Resources. And all of these are validated through the efforts not just by PhilSA or DNR, but by LGUs, citizen scientists, and local partners such as even schools. No? Currently, there's even a residential directive to engage universities, high school, and even college students in validating this type of data sets. No? Moving forward, we hope to produce mangrove extent map annually and create those data layers and examine the changes that we see in the environment, at least in an annual cycle. So this is the example. This is the map that is now shown in the National Museum as a way to show how we can benefit as well from this type of data. We are also extending, for example, the analysis not only to the extent, but also to the zonation. If we look at blue carbon, we need the species, we need the genus type, we need the height, we need the basal area, and so many things in order to calculate the above ground biomass. Those things are very important, and some of them can be estimated using remote sensing. So this is our paper on mangrove zonation. We utilize different indices derived from Sentinel-2, as well as those biophysical that can be estimated from LAI. So this means you can use LAI, you can use chlorophyll content. You can also use even the case of, say, potential active variation, F4, fractional cover, and so on. So if you look at the case of Busuanga, no, in northern Palawan, we can see that we can delineate mixed mangrove zones or areas dominated by rhizopora, areas that are sparse or damaged, and so on. No? So this has been done for the entire Philippines. There are also labeling that has to be done because the approach that was done here is basically unsupervised approach, or basically clustering of the different areas using the features that we have inputted to the algorithm. Okay. And the effort is also going towards the estimation of above ground biomass. So we have to do this in order to quantify the sequestration and storage potential of mangroves. Particularly, they store in the above and below ground through the roots, but also they sequester and store carbon through their sediment organic matter. No? Okay. So here we utilize different data sets. Sentinel-2, I think even Lancet and SAR, no? To estimate the above ground biomass in 25 by 25 pixels for the entire province of Zambales. And mind you, this is an undergraduate project. We are now preparing a program or a paper for this. No? And the one who did this is now employed at the Philippine Space Agency. We work with scientists. For example, Dr. Samo, one of the advisors, is an ecologist. He's an expert in mangroves. No? and he's a professor in the Institute of Biology and so on. We are not a domain expert. We can maybe do some mapping, we can do some level of AI, but we have to work with the scientists in order to get the proper interpretations, even the data that are needed in order to generate such product. So this is also very important, land surface temperature. I saw Engineer Mylene, his thesis is actually more on land surface temperature and urban heat islands. So we have to also explain the distribution of this LST and UHI through these images, through the calculation of unit thermal field variance index. But we also have to know what explains this variation. Is it due to the presence of vegetation, built-up index, and so on? But we can estimate them using different indices, using different explanatory variables, and so on. But we can also do more things. For example, combining higher resolution images like PlanetScope data and the Landsat, which is 30 meters, to produce or to possibly explain what is the impact of different building footprints, locations or patterns, as well as the geometry, the 3D variation, and so on. So our next paper was looking at deriving, for example, correlations of textures. Texture can indicate patterning. Textures can indicate also clustering of buildings vis-a-vis vegetation and many other things. So if we look at GLCM, which is a popular texture measure, we can also explain the variations of land surface temperature more effectively compared to just using the typical vegetation index or built-up index and even the sky view factor, which relates to how much sky is basically available in that particular area per pixel. So now we go to the benthic habitats. And as I mentioned, we produced the 2023 mangrove land cover map. We now have an agreement with DNR to produce the seagrass cover, benthic habitat cover, coral cover for the entire country this year, and we hope to finish it maybe in the Q3 or Q4 of this year. So now we are starting to mobilize volunteers in order to get validation data sets, test data sets from all over the Philippines, particularly in those areas that can be accessed, the seagrass areas. So as we can see in this picture, we have drones, we utilize different cameras and so on to go to the field and also do our transects in order to test our methodology. So we've been to many coastal areas, including Puerto Galera, and this is another example of the benthic habitat map of Boracay Island, showing in detail certain areas, particular seagrasses and corals and the sandy cays for that particular island. Part of the agreement with the DNR is to produce the first ever, percentage cover of seagrass in the country in the seasonal basis, meaning not only one per year. So we are using this methodology that has been developed in the previous project funded by DOST and JICA. So here we see that we take pictures from drones, and those drones are actually taking pictures ultra resolution with the level of maybe a few centimeters, 5 centimeters. And from there we calculate the seagrass percentages, we map the seagrass at that particular level, and we calculate per pixel of sentinel to 10 by 10 meters, the amount of seagrass in that particular area, and utilize machine learning algorithms to calculate the distribution of percent seagrass using those ML approaches and Google Earth Engine. So we can see the example of Prieto Diaz in Sorsogon, where you have dense amount of seagrass, particularly in the southern portion. So this variation is very important because seagrass, unlike mangroves, they are highly dynamic. They change their density, they can be buried by sand, and those so many other things that affect their growth, including turbidity and water quality of those coastal waters. In another project, we also utilize models which are based on, it's not animating, based on neural network. So we have the C2RCC approach. So this is from a DOST-funded Manila Bay project. And in the video, I also noticed that you have also segmentation. This is very important in the case of this type of mapping and monitoring, including this oil spill monitoring, which happened in Mindoro as well as in Manila Bay. I think this is a part where we need also assistance from the team because this one is a bit slower because I think we typically use the initial segmentation. We try also to infuse some interpretation on our side, because wakes from buildings or from islands may look similar to, say, the darkness of the oil spill as it appears in a SAR image. No? Okay. And recently, we signed a memorandum of agreement with NAMRIA. In NAMRIA, they can do a lot of bathymetric survey, but only in deeper waters. It's very difficult to survey in shallow waters, in reefs, or in sa mga bahura, no? But they need those type of information, so we will collaborate on land cover, benthic habitat mapping, as well as in estimating shallow water bathymetry. In this case, we can use, again, multiple data sets. So we have ISAT, is also a LiDAR, and those paths there are basically LiDAR from different dates, no, 2018 up to 2022. And then we can, of course, similar to what you do, we can generate a model to produce the estimation of those bathymetry data. No? So this is an initial estimate. So R squared is around 0.85, no? And RMSE is around 1.7. No? This is comparable to researches that were conducted by STAMP, but utilizing, for example, other multispectral data sets. No? So this is an example product for the area of Bolinao in Pangasinan. This is a favorite spot because we also collaborate with the UP Marine Science Institute. They have a lot of data in this region. So they have soundings, they have water quality, and also they monitor those benthic habitats. No? Here we can see that we can fairly map in good quality the bathymetry of these shallow waters. Of course, these are affected by the quality of the water. If your water is turbid, then most likely you will not be able to get a very good estimation of those bathymetry. For clearer waters, it will work the best, no? Like in the reef area or in maybe areas with where the turbidity is acceptable to a certain extent. No? This is one of the things that I was before I went to PhilSA. No? So they created these potential fishing grounds. Combining, for example, chlorophyll aid estimated from satellites, also the sea surface temperature, and many other things. Though. But I think this one needs further development in terms of continuing it, because this one already stopped after doing, I think, the initial model. And we have to do this per species, for tuna, for example, for salmon, or for other fish, no? For sardines, which are relevant to the Philippines. So Indonesia, they already have such model. No? So collaboration with the relevant agencies and universities will be very good. So I have 7 minutes. And now we have this COPIL, the National Copernicus Capacity Support Action Program for the Philippines. This is a program conceptualized in DOST. So this is implemented jointly by the DOST, the Philippine Space Agency, and the European Space Agency. No? Okay, there are several agreements signed, the technical cooperating agreement, and many other things now. And this consists of the mirror site. The mirror site is now, the servers are actually at the customs. No? It will be released and deployed in the servers or the racks of DOST ASTI. And probably it will be operational sometime in April or May, depending on the commissioning phase. No? But the data are already there, no? already in those servers. But another thing is that we are developing or co-developing with different agencies the monitoring services. No? So this includes the ground motion. So we know that many institutions, like in particular FIBOX, they are doing ground motion studies. No? Land cover for crop mapping, benthic habitat monitoring service, no? Including coral bleaching monitoring. No? I think the most challenging part here is the crop monitoring, because this requires mapping of several crops: banana, coconut, coffee, pineapple, sugarcane, rice, meron pa yatang rubber trees, mga ganun, no? So data should be, there should be more data actually. So now we are mobilizing also the LGUs, trying to ask their help and assistance in addition to what data that can be provided by the Department of Agriculture in basically identifying those different crops, no, using some mobile applications. And this is, I think, the latest part, more on the super resolution. So in the super resolution, what we would like to do is to super resolve Sentinel-2, which is the highest image resolution is 10 meters, and make it at the level of 2.5 meters, using deep learning approach. There will be a technical assistance by ADB to PhilSA as well as to the Department of Human Settlements and Urban Development in order to do this super resolution mapping. And I think the labeling and all those access to data, very high resolution satellite data, holdings of the USC ASTI, as well as PhilSA will come handy in this type of development. Okay, so that's all for my presentation. Thank you very much, and we look forward to collaborating with you all.
Thank you, Dr. Blanco, for sharing your expertise and providing a fascinating glimpse into the exciting field of space data mobilization and AI. Now, with great pleasure, I'll introduce our first resource speaker. She is the Director of Space Science Missions Bureau of the Philippine Space Agency. She leads the research and development initiatives across diverse disciplines, integral advancing space science missions that would drive national and economic growth and foster scientific progress. She obtained her high school diploma from Philippine Science High School main campus, Bachelor of Science in Physics from Ateneo de Manila University, Diploma in High Energy Physics from Abdus Salam International Center for Theoretical Physics in Italy, and PhD in Astrophysics from Princeton University, USA. She was also a postdoctoral fellow at the Kavli Institute for Cosmological Physics at the University of Chicago. Prior to joining PhilSA, she was an associate professor at the National Institute of Physics, University of the Philippines, Diliman. She received the Outstanding Young Scientist Award for Astrophysics from the National Academy of Science and Technology. She is passionate about building a more nurturing, empowering, and inclusive ecosystem for scientists, researchers, and innovators for the benefit of all Filipinos. To give us a presentation on applications of AI in astrophysics, requesting everyone to turn your attention to the screen for Dr. Reynabel Reyes.
Good morning, everyone. I'm Reyna Reyes, and I'm here to present our work on AI applications for galaxy classification. We have solidly entered the big data era in astronomy, where sophisticated telescopes produce a lot more data, both in quantity and quality. As an example, you may have heard of the James Webb Space Telescope, which is the newer, better version of Hubble Space Telescope, and it transmits 50 gigabytes per day versus Hubble, which produced 1 to 2 gigabytes per day. And we are entering into the petabyte era with this new generation of telescopes and surveys. And that astronomers are now complaining that these new telescopes are producing too much data too fast, like a fire hose. And we are, at the same time, we have now the new technology that will allow us to process and analyze and get insights from these vast amounts of data in reasonable time. To give us an idea, this is the just one of the deep fields. In fact, this was the first deep field that James Webb Space Telescope produced. It looked at a large galaxy cluster, and you can see here the richness of the data, hundreds of galaxies, all different types. You can even see the gravitational lensing caused by the cluster, the galaxies in the middle of the picture. And we can get so much physics and so much understanding of how the universe works and how the universe evolved over time from these deep field images. And you can also imagine the challenge, because now You cannot do manually inspect and manually classify different types of galaxies, but you have to do it in an automated, intelligent way. Of course, in the olden days, we did that visually, and Edwin Hubble was, in fact, the first one to systematize the classification scheme for galaxies, and that's still used today. Basically, you have two types of galaxies, ellipticals here on the left, which are round and smooth, but with different ellipticities. So from round to flatter. And then on the right side, you have our spiral galaxies, just like our Milky Way. We have more structure. You can see spiral arms on the right side. And then there are two types, barred and unbarred galaxies. There are also a third type of galaxy called irregular galaxies that do not fall into either of these classifications. So by eye, you can actually tell what morphological type a galaxy is, but the challenge is how to get a computer to do that automatically and accurately. So to solve this problem, a bunch of smart dudes, smart astrophysicists came up with the Galaxy Zoo project. And here it is a citizen science project where volunteers from around the world help classify galaxies. They're given these images and then a set of questions. For example, here, describe the galaxy into is it smooth and rounded with no sign of a disk? And so you can choose, and then you get another question based on the answer. And based on these responses in this decision tree, you get classification, and you can compare the classifications of different volunteers of the same image. And based on these votes, you get an assignment for the classification of the galaxy and a confidence on that classification. So thousands of galaxies have been labeled this way. And as we know, once you have labeled images, you can form a data set that can be used to train different models, neural networks, to classify new images. So for images here on Earth, we have ImageNet and other data sets. For galaxies, we also have several data sets. What we use in our study is called the Galaxy 10 decals dataset, which are based on images from the Dark Energy Camera Legacy Survey, classified into 10 morphological classes illustrated here. And in total, there are around 18,000 galaxy images in colored images in the G, R, and Z bands. And these 10 classes are listed here. So you have not just the smooth versus spiral, but within the smooth galaxies, you have different classes, round, in between round, and cigar-shaped galaxies in class 2, 3, and 4. So you can see there the Hubble sequence as well, where you have flatter, from round to flat galaxies. And on the second row, we have the spiral galaxies, barred and unbarred, and then seen edge on, because they would look visually different than if they were face on. So the last two are edge on galaxies with and without a bulge, without bulge and with bulge. So these are all labeled images. and we can now apply different approaches to perform classification, test how well different models can perform classification. So in this talk, we'll be sharing about some work that we've done with collaborators to use CNNs for galaxy classification and VLMs as well. And then we'll end with a bit of a teaser of ongoing work going beyond classification with the SkAI-Pinas and Asimov-Hawks teams, in particular looking at object detection, reclassification, and generation of synthetic galaxy images. So for the first work, many of us are familiar with the use of CNNs for image classification. So you feed in an image of a bird, train the model to say that this is a bird rather than a dog or a cat, and then do that many, many times. And then if you feed it an image of a bird, it can now say that it is indeed a bird. So we apply the same technique. We've chosen as a starting as a starting point two CNN architectures: Inception v4 and ResNet 101. Inception v4 has this inception block that allows for different types of sizes of filters, and the ResNet has a residual block that has a shortcut or skip connection that allows deeper networks to be trained. We also apply data augmentation, illustrated here by spatial transformations, including randomly rotating the image 90 degrees, or multiples of 90 degrees, flipping the image horizontally or vertically. We did both offline augmentation, which happened before the training phase to set the size of each class to be equal to 2,500 images each, and online augmentation is done during training phase to increase the diversity in the data seen by the model. And here are the overall performance metrics. We see that ResNet 101 performed better, slightly better than Inception v4 across all metrics: training accuracy, validation accuracy, and then in the test set, accuracy, precision, recall, and F1. We can also look at the classification performance in more detail by looking at the confusion matrices. And here we see the 10 classes and see that ResNet 101 model performed well across all classes with over 75% accuracy. We see that it misclassifies the unbarred loose spirals most and confuses them with unbarred tight spirals most, and also disturbed galaxies. So this is just a starting point in illustrating that we can run these models, and we find that we can get accuracies, performances that are at par with what's in the literature. And now, in collaboration with Doc Joe and the SkAI-Pinas and Asimov-Hawks teams, we are running a larger set of models to study which architectures are best and most efficient in classifying galaxies. We are also studying how this depends on the galaxy properties such as size and brightness. As another experiment, we have experimented in using the most recent transformer models, visual language models, to classify galaxies using simple prompts. So we're familiar with OpenAI. It's trained on vast amounts of data from the internet, can be immediately used to classify any image. We can use the OpenAI API, And you can use zero-shot prompting. Just give the galaxy image and text instructions. Downsides include lack of info about the architecture, which is proprietary, and still limited established performance metrics. If you could ask the question, can OpenAI VLMs be a good alternative to CNNs in classifying galaxies? And this work was presented by our collaborator Lance Lagman at the annual meeting of the Physical Society of Taiwan last January. For the methodology, we tested two models, the GPT-4o and the GPT-4o mini, which is a lightweight version that is also cheaper. And for the setup for this preliminary test, we just used 100 images per class with these parameters and performed tests for 10 class, just like in the first work, also 4 class image classification, where similar classes are merged. So the pipeline is actually very simple. You input the galaxy image and the prompts, and you get out the classification from 0 to 9, and then compare it with the labels. This is the system prompt that was used. You are an experienced observational astrophysicist specializing in galactic morphology, and then describing what it should take note of, and that in the end, it will reply only with a single integer. And these are the user prompts for the 10 class. So for each class, from 0 to 9, there's a short description of what that galaxy looks like. Similarly, for the 4 class, where it's just irregular, smooth, spiral, and edge-on, we have a description of what each galaxy looks like, and prompt to provide the corresponding number. And how did this perform? Well, we find that for the 4 class image classification, it performed decently with around 80% accuracy. But for the 10 class image classification, it failed. Didn't do so well with just around 40% accuracy for both models. We can also look at the confusion matrices. So for the 4 class classification, we can see that the GPT-4o model performed better with around 70 or above 70%, around or above 70% accuracy across all types. The edge-on, as you can see in both models, of course, almost perfectly classified because it's most distinct visually across all. So this makes sense and shows the potential for using, just prompts to classify galaxies, at least at the level of these 4 different classes. And now this gives us confidence and ambition to go beyond classification, this early work. So this is ongoing collaboration and ongoing collaboration with Dr. Joe and his team. And here is just ongoing work. So preliminary and just as a teaser, we've been able to apply object detection on these galaxy image fields, and the bounding boxes are identifying where the galaxies are, and then also already applying the classification. And we would improve this over iterations. And another work stream is through generating synthetic images to be able to multiply, diversify even the data that our models can see. But as you can see, there's additional time might be needed to make these more realistic. But mostly also that this is what I put on the title slide, and at first glance they actually look like real galaxy images. So again, it's showing promise. We're excited about this line of work, and we look forward to making more progress and reporting our work in the future. So recognizing our collaborators, Lance Lagman of CSRC in UP Diliman, Jess Ibut at the National Institute of Physics in UP Diliman, Doc Pros Naval at the Department of Computer Science in UP Diliman, and Doc Joe Rubico and SkAI-Pinas and Asimov Hawks teams who are also very kind to invite us to share our work today and to organize this very nice Congress. I'm sorry I couldn't join you in person, but I wish everyone a good rest of the conference, and I look forward to sharing, discussing with you. Please feel free to reach out to any of us if you would be interested in learning more about this kind of work, applying AI to astrophysics, to observations in space. Thanks again for your attention.
Thank you, Dr. Reyes.
At this point, we'll now take a brief interlude to allow our guests and speakers for a quick break.
While on a quick break, dear guests, we invite you to share your thoughts by completing our event evaluation form. Simply scan the QR code on the table tent at your tables or on the LED screen and fill out the Google form. After submitting the evaluation form, please capture a screenshot on the confirmation page. This will serve as a proof of completion, which you can present at our secretariat table to claim your certificate of appearance. Thank you very much.
All right, Renz, I guess everyone is refreshed and already settled.
Again, we would like to thank Dr. Reyes for your insightful video presentation on AI applications in astrophysics, inspiring us to explore the transformative impact of AI on our understanding of the universe.
Yes, with that spark of curiosity ignited and our minds buzzing with new ideas and perspectives, let's proceed to our next presenter, who will surely continue to fuel our passion for learning and exploration with a presentation on ethics of and around AI. Our next speaker is a recently retired full professor at the College of Computer Studies and a university fellow at De La Salle University. He holds a PhD in computer science from INP Grenoble, France. He has been teaching undergraduate and graduate courses in theoretical computer science and intelligent systems. His research interests include text and music mining, as well as various applications of artificial neural networks and machine learning, including generative artificial intelligence. He had been a senior research fellow at the National University of Singapore, working on the very large program for research into intelligent systems. Other than his qualification and experience in teaching and research, he has also been trained on university leadership in Kassel, Germany, and in Rome, Italy, and is currently a senior quality assurance assessor and trainer of the ASEAN University Network. At DLSU, he has been graduate director, vice dean, Dean, Associate Vice Chancellor for External Relations, and Vice Chancellor for Research. He was also the first Executive Vice President of what was then De La Salle Canlubang, a member of Mensa since 2005, and a member of the AI Board of the Department of Science and Technology. Ladies and gentlemen, a warm round of applause for Dr. Arnolfo P. Azcárraga.
mahaba yata ang introduction. No, I was worried we were 30 minutes behind schedule, and I have been deleting slides upon slides since last night, so I'm down to still about 80, so I'm really, and you'll understand why. Okay, so I entitled it Ethics of and Around AI, because some of the things actually when we talk about ethics would really be, you will see, would really be about the kinds of things we do prior and around and the deployment of it. And so I thought this was a more apt title. It's going to be long because I thought that for us to talk about it, we'll have to talk about the context, the current context now, which is really generative AI and the mainstreaming of AI that has entered society, and AI being in our phones, AI being in our living rooms, with a camera and a microphone, sensors all over. And these data are really just going around, swirling around the world with all the potential risks and harms. And so parallel to that, we have a quest for ethical, responsible, and inclusive AI. So I just wanted to set the context for all the talks about ethics and the regulatory frameworks with some slides that I have used before about the mainstreamed AI. And then really just to complete it, I thought that if we talk about the march towards singularity, which will be in the lifetime of many of you here, will happen, then all the things that we will see as far as regulation and ethics of AI will essentially be thrown out of the window. Because then machines will be deciding for themselves, and the harms that we attribute to humans might not work. So we'll have to rethink our frameworks. Anyway, so let me go quickly with the first part. We know that really it's really around 2012 when deep learning broke ground. Of course, we've been working on it decades earlier, but there was this ImageNet contest in the data set that was started by Fei Li in Stanford in 2010. Really, the objective was really just have 1,000 categories. You'll have to find the top 5. You have to hit the top 5 categories for every image. And there were thousands of them initially, and now 12 million images. 22,000, categories initially. So anyway, since then, you have the likes of Geoffrey Hinton there, the students of Yann LeCun. They all were winning it year after year after year. And this is really the convolution neural networks of 2012. And but then just to be sure, just to be clear, that AI had been percolating all along since the summer of 1956 at Dartmouth College. And this was at during that time, the generation of Marvin Minsky, John McCarthy, Rochester Shannon, and other people like Herbert Simon, Alan Newell, and the others, who were there in the whole summer of about 2 months, talking about AI just being there around the corner, that they will be able to develop an intelligent system that would match the capabilities of the human brain. Of course, we went through AI winters and summers, flops and disappointments since the 1950s. And it just so happens now that the summer is continuing. Since 2012, we haven't seen it dip. It has just grown and grown. And by 2022, right coming out of the pandemic, the world was surprised with ChatGPT 3.5 that came out hugely successful. Your grandmothers would use it. Your kids can technically use it. Mainstreaming in the sense that unlike the the GPT 1 and 2, we were using it in 2017 in the graduate school in LaSalle. But 3.5, this was used by anybody. And suddenly people were talking about cheating in schools and how AI can destroy society, etc. So that's the context of all these quests for ethical, responsible AI, because suddenly AI was not anymore used just to classify objects. Is it a Galaxy 1 or Galaxy 2? Is it a dog or a cat? Now it's really, you talk to it and it will tell you its dreams, it will tell you its opinion, and in a language that is really human-like. Okay. But to think that this transformer-based ChatGPT at the start was only designed to predict the next word of a phrase. So if the phrase is like this, it has been a very long day, my talk has to be blank. It will give you words with a probability. It should be lively, it should be short, it should be informative, it should be apple. See, apple, the probability is very low. But maybe it should be lively, or I should be informative in this talk because, you know. Anyway, so from there, it was just a translation of English and French. From there, you've developed into best words in a whole string, a sequence of words, and then all of that aided by lots and lots and lots of data. So I think ChatGPT 1, 2, 3, and 3.5, we had some technical information about the kinds of data that were fed. Of course, there were litigations afterwards that somehow they sounded like some editors of some newspapers in the US, and they were charged for actually not processing, but really just resurfacing works, copyrighted works by other people. And so I'm not sure now. I think ChatGPT 4.0, we already don't know exactly what we're fed. Maybe it has now become a trade secret. We don't know anymore how much in terms of terabits of tokens have been given, and the size of the window, of the context, etc. So this is in 2017. The seminal paper on transformer is entitled "Attention is All You Need," and I'm using this because transformers at the time, 2017, have been able to break loose from the severe computational limitations associated with the use of long-term, short-term memory (LSTM) and the recurrent nets, which had potential but were ultra slow. And the other thing that was very important, this is related to the labeling that Joe is doing and that the Rain earlier talked about. In the realm of speech, natural language processing, ordinary pictures, etc., you really, with all the millions and billions of tokens out there, you really cannot label them. And we were struggling with it. My PhD was on self-organizing maps way back in '87, and we were in the field of neural networks. We were two opposing, fighting, competing groups. We were the self-organizing, unsupervised group, and all those doing backpropagation were in the supervised, and they needed labeled data for each. For each input, you have to say category 1, category 2, etc. And we thought we just could not do it. We cannot upscale that in the real world. And so things merge eventually. Neural networks a la backpropagation merge with those doing unsupervised. And I think I have to credit this to Geoffrey Hinton, who worked with SnE, which is really the modern version of self-organizing maps, where it's really how words are positioned near each other, and you basically just figure out the label of a word by itong sinasabi, we judge a word by the company it keeps. So if a word keeps on appearing with positive kinds of words, then you sort of like slowly get a sense of it. You don't have to say this is a noun, this is a verb, this is positive, this is negative. It's really just by its use. And the billions of phrases uploaded to the internet, was ripe and was just there for these kinds of models to work. So you have the GLOVE and the Word2Vec and all those algorithms that came into the picture. And so eventually we had these large language models that really did not need labeled data. Ayan si Elmer Peramo would lecture you about natural language processing, that's his field. Okay, so mainstream AI, from my point of view, was a confluence of factors. And just like drugs and molecules you put together into a super medicine, you have one, I'm sure you will add to this later when we discuss the cheaper, more powerful computers, the Murphy's Law, Moore's Law. The Moore's Law just continued and continued and continued since the 70s. We had cheaper, more and more powerful. So the power doubled, the price halved. And the GPUs, you know, NVIDIA became super valuable as a company because of the GPUs. And you now have football courts of buildings, entire campuses just of computers working together to do all these large language models, for example. And that all of these machines, your cell phones, your computers at home, the mainframes, they're all interconnected via the internet and an earlier discovery. And that led to the abundance of data that AI would not have been possible without those data. And then there were just so many, it became a no-brainer that we just cannot label the data anymore. So we had the non-dependence on labeled data became a crucial factor for mainstreaming of AI. And then parallel to that, the huge progress in machine learning and algorithms in general, plus organizations like OpenAI, DeepMind, Google, Meta, and all those, and the universities, of course. So we are used to this now, AI that can talk, listen to you, and joke with you, offer you opinions, do things for you. They can move, walk, dance, self-drive. They can recognize you, your twin, your mother, and tell you your friends are in this group photo. They can recognize you. And other you-machine abilities. You give a 1 minute, 2 minute version of your speech, and they will analyze your facial points, and you can talk like Barack Obama, and will smile when what you're saying is nice and happy, and will frown and be serious with cross eyebrows if it's something serious. So we can literally make Donald Trump declare martial law suddenly on a Friday midnight. And you don't know anymore if it's true or not, because it will come from his lips with his own usual expressions, and everything is empathic, etc. These are interesting times. Neural style transfer, you take a photo, you want it painted like Picasso or Van Gogh, easy. That's a very old technology in 2016 that continued to work. I have a student, Virtucio, who is now a Balik scientist, who did better than the best in the world. I'm really sure he was the best at this time. It was a joint master's between LaSalle and Taiwan Tech when he did this. He used the covariance matrix instead of the Gram matrix of Gattis. And he was doing so much better than all the others. And he could control how much of the input and the pattern and how much of each one you'd like to do. You just move it. Very good work, and I putting up this slide because it's really, we are now part of that world of mainstreaming AI and all that. The Philippines can do that. You just saw what Rain could do with the galaxies, just like what the people at Stanford are doing. And this is even just an undergraduate student who happened to be an artist and work with a Malikhain project where you have amateur work of youth that you combine with famous works of artists in the Philippines to create a generated output that's generative AI. This is the Tisney I was saying, student of Geoffrey Hinton at the University of Toronto. And the deepfakes was also a very important development where deepfake was not the newspapers speaking badly or talking badly about computer science. Deepfake was an objective. We wanted deepfake as a research goal. We wanted to be able to create pictures and videos and poetry and all that that are indistinguishable from what humans are producing. So they are very deep fake that is so difficult to distinguish from what is real. So here, each one has a real and an unreal. It's up to you to check and use your instincts to know which one is real, which one is fake, but not easy. But you know, you can also say these are the usual bags. I'll just give you a sketch. Give me a new bag and different designs. Play around with the designs. It can be used for ideation. And the idea is actually very simple. And these are really, you have two modules of a system. One very good at discriminating whether it's good or fake or real. Fake, real, fake, very good at distinguishing it. The other one is just producing fake. And they try to beat each other until they are both good. So, you know, these kinds of algorithms, this is the famous GAN, generative adversarial networks, which led to a lot of versions and a lot of applications. And these were actually used for the data augmentation that Rain was talking about. When you need more data and you don't have too much, then you use GAN to produce more that are quite realistic anyway. So, yeah, so that's an example. But they can also be used for many other things. So just because they are deep fake can also mean that you can produce pictures that will harm people, that will question our justice system. Where you use them as evidence and suddenly they are really fake. And all those that you can imagine. So this is another student. He finished his PhD just a few weeks ago using style transfer to design industry products. So you can take an IKEA chair with no personality and mix it with something from Kobompue and produce new chairs, new fabric, new materials, etc. So he finished his PhD in Japan. A master's was done here, then he finished in Japan. So you have this now generative AI, which is really not used to forecast the next US dollar exchange rate with the peso or forecast things or classify. It's really just to create, to generate content. So you want you're doing a film about an astronaut riding a horse in some desert in Australia. You can use generative AI to do that. You don't have to mount an astronaut with a person with a... So just generative AI, you can have that. I know that at the Film Institute in UP, the use of generative AI is part of the curriculum. So you use first generative AI to prepare your first video version, then you augment it with your own personal style, and you learn by doing AI first. And you learn with AI because that will be your world after you graduate. And there are other things. I want a sofa, a couch that looks like an avocado. You have that. Yeah, I want two cats playing chess against each other. You can have that. So yung mga journey, mga ganyang style, medyo dark. You have that as well. And then, of course, you can imagine all kinds of issues. And now you have text to video, text to music, and all that. When we teach intelligent systems, we talk of whether you're after thinking or some behavior, you want it to look like humans or you want it just rational, doesn't matter if it's not humanly. So the most part, we are in this quadrant. You are not necessarily human, but rational. So you do it correctly, not necessarily the way humans do it, but do it correctly. And we're attacking not just thinking, but behavior. So it's about picking an egg without breaking it, delivering a box, or singing, or writing poetry, all those. So many things other than just thinking. As opposed to dati, you declare everything, you program everything. You say, if it hits a wall of a certain angle, turn this much or that. So everything was very predictable. And now we're nearing ethics. At that time, it was very easy to prescribe the accountability, right? Because the person really programs everything. And now with the procedural, sorry, the declarative is you say these are the facts of the world, these are the rules of the game, and you basically merge them. But now with machine learning, you really don't prescribe how the machine will do it. You just give him the data and the machine will figure it out. So it's quite harder now to really pinpoint what the person wanted to do via the machine, right? Because you are allowing a machine to learn from what you give it. So with that as the backdrop, we have to think about how do we deal with the possible risks and harms of AI, and how do we make sure that the poor and the marginalized will also benefit from all the potential good things coming out of AI. So I will skip through all this, but just say it has been by now a 70-year adventure of AI since the 1950 paper by Alan Turing. The bar at the time was just to say, I don't believe machines can ever be intelligent like humans until they can write a sonnet or compose a concerto. We have done that years ago, right? We have been able to write sonnets using machines. So we've really surpassed the challenges posed by Professor Jefferson at the time Turing wrote his paper in 1950. And interestingly, Turing said, you are skeptic about AI. He was telling Professor Jefferson, you are skeptic about AI because you have not seen intelligent machines. You have not experienced it. Count 50 years, so that's year 2000. Count 50 years, you will see more and more intelligent machines and you will change your mind. And true enough, we now have machines that are able to write novels like Leo Tolstoy. They can write sonnets like William Shakespeare, compose music like Beethoven, and many others. And we've actually done experiments to compare human poets and machine poets with experts who would not know whether it's machine or... And machines can compete well in sonnet writing. In fact, there are some places where they're better than humans, okay? And the movies, in fact, in 1956, a concerto, or it's a symphony, was composed by Ilyak 4 at the Ilyak 1 at the University of Illinois in 1956. The entire composition was played in the University Hall at that time. So, you know, some of these things we feel are super new. They have been there a long time ago. Anyway, so it's easy for factual probes, but they can also do poetry for you. It's incredible how much we have achieved over the 70 years. So just to lighten the mood before I go, ethics, full blast. How much time do I have now? I was, last weekend was our 50 years of friendship since high school. We entered high school in 75. So we were doing possible logo. So in 1975, 1979, the batchmates were divided. Some liked it, some did not like it. Too many complaints. So I went to ChatGPT. I asked him to design the cap na lang. Let's not design it ourselves because there are too many complaints. Let's ask ChatGPT to design it. When I showed them this, sabi na, oh, okay na yan, okay na yan. So this became our souvenir cap. It was DALL-E. DALL-E is now part of ChatGPT 4.0. Okay, so let me go through this ethical. So you will see that AI is strong. It has a lot of diverse and powerful applications, right? And pervasive. It will chase you in your bedrooms, you know, in the morning. It can do your coffee at a time that you designate it to do it. It can find drugs for miracle cures for special diseases. Assembly lines, transportation applications, so many things. But it has also a diverse range of potential risks. Surveillance, privacy, cybersecurity, discrimination, biosecurity, malicious use, all kinds. So you will have to deal with all the scary things that can come out of AI, and we'll have to talk of ethical and responsible AI that is safe, transparent, respectful of human dignity. But at the same time inclusive. So you want it to flourish, you want it to succeed because there are so many people, all kinds of people sana will benefit from it. But in an ethical and responsible way. So the balance is what is hard to achieve, and the key is really to do all of that without stifling innovation. Okay, and that's the key. This is the slide that I got from last week. I just noticed it looks like a key. Tama ba? Or it's just, this is my imagination. It looked like a key, kaya nilagay ko, just in case you missed it. So, there are general regulations. That regulation, it's general considerations. A regulation about AI can actually not stifle, but enable innovation, because things are, the ground is clear, you know you will not be sued, you know how to do it properly, you're guided by regulation. And then there is public trust when things are in place and things are clear. Okay? But AI regulation does not occur in a vacuum. We already have laws about drugs. We already have laws about consumer products and all of those. We have laws about data privacy. So we can build on those suitable for the Philippines. But we have to know that it is pervasive and context-specific. So I received this, during the pandemic, I received this working document. We had about 2 months to work on it, asking for comments. So I received this, and then it became this by September the next year. You find this is a very good source of input. UNESCO, I feel, did a very good job at putting all the world's anxieties and concerns about AI in this website. It's in a website that you see the publications, the recommendations, etc. But I'll just concentrate on a few. These are voluntary. The way UNESCO does it is voluntary, non-binding, but strong in recommendations for member states to consider. It defines values and principles. So meron siyang very clear core values that we need to protect, and it has principles that will operationalize it. Okay? So let's just go through some of them quickly. Human rights and human dignity must not be trampled upon. You have to be respected, protected. Okay? We have to continue living in peaceful, just, and interconnected societies. Just because AI can harm some of these and is actually using our interconnectivity to do all of these possible harmful applications, we should not stop living in peaceful, just, and interconnected societies. And there's also this diversity and inclusiveness. And the amount of power that AI is using can harm the environment. It's just too much power just to run those machines. So this is what I said. There are 10 principles that were used to operationalize the core values. For example, the AI should not get too much info, should not turn on your microphone if all it needs is text, you know. Minsan may mga ganon na apps, di ba? Kung ano-anong permission hiningi sa'yo, wala naman siyang hiningi pa niya GPS mo, nagte-text ka lang, no? Or mga ganyan. So, proportionality and doing no harm. Safety and security, of course. But there are 10 others. Let me just put them all. We will not have time to go through this. But you will see things like right to privacy, for example. We have to know who is accountable if something happens. It has to be able to explain. Explainability is nice. If you notice ChatGPT before, parang, basta this is the conclusion. Now, these chatbots will tell you how it arrived at a conclusion. So, and it also tells you that it's not so sure. So it's probably, it uses words like this now. It's not so, I mean, when it's not sure, it's clear that it's not sure. Okay? And explainability is because it explains to you its logical process. But explainability goes further in other forms, not just the chatbots. Sustainability, awareness, literacy, fairness, and non-discrimination. This has always been a problem because of the data that we use. The data might be biased, so the app can be biased at times. The OECD has the same thing. You have core values and you have principles that are built on these core values. And then you have some recommendations for policymakers. Like you have to invest in AI R&D. Don't block it. You have to invest and promote it. You have to foster a digital ecosystem in terms of collection of data, for example, so that you can have good services in government, for example, in hospitals, in schools, etc. Others. So this is the workshop we attended last week. Joe was there with me, the others here. The Alan Turing Institute of the United Kingdom came here for a whole week, talked about AI governance and knowledge and capacity building for all of these ethics in AI. And so I've been using some of their slides. A few I've used already, like the key, the key slide was from them. But I'll just put here the more important things. There is a document that by Dr. David Leslie on understanding AI ethics and safety. A lot of it are there already. It usually follows the same progression of UNESCO. You have the values that you want to protect, and you build on, for example, here it is the respect, connect, protect, and care. And then you have to build in the principles that you operate on, building on those values, right? So sustainability, accountability, explainability, data stewardship, fairness, and safety. So the framework is really always like that. You have things that are very clear to you. You have to be very clear about the values that you want to protect. You operationalize that with principles that are pretty much generic. And then there's the process-based governance. That's where you put in all the legalities and the accountabilities, etc., to implement this level 2. So it's always like that. And this is a reminder, ethics is knowing the difference between what you have the right to do, hopefully this is not our basis, and what is right to do. Right? So I think we've heard that different versions of the same thing. Even if you have the right, no law against it, but if it's not the right thing to do, then you are not being ethical. And this notion of responsibility, ideally we are responsible. Of course, we need to be accountable if something happens, but accountability goes backward. If something happens, you go backward all the way to pinpointing where it happened. But responsibility is thinking ahead. So as you go along, already think of the future of whatever might happen. And so I think this is an important message that we need to be responsible as we build AI and looking forward already in terms of everything that can happen. And then truly remain accountable. So if you have an AI project life cycle, the recommendation is to consider the ethical issues and impact at every stage. Right from the design, iniisip nyo na yung impact and ethics, all the way to developing, choosing your models, testing them, etc., and deployment. So that's the key there. At every stage, look at the ethics and the impact of AI. And then all these notions of fairness in the way data are chosen, in the way the models are tested, in the metrics that you've used, and all the other things. And that accountability, this is what I meant, some of this will be challenged. The accountability remains with the humans. You cannot say AI yan eh. Machine yan, I don't know how he did it. In the end, the humans will have to be answerable for the parts they play across the AI design, development, deployment. But when I ask them, so for example, a Tesla car hits someone, is that going to be, is the programmer who did the original navigation, is he accountable? Is it the data? Is it the company who is selling you? Is it who? Is it the driver who did not do anything? But self-driving guy, So in the end, they apparently could not. They wanted to pinpoint every turn who the accountable is, which human person in the process is accountable. Pero parang hindi siya as easy as we thought. Okay. This traceable from start to finish is a goal, but it's hard to achieve. And there's also, it's not easy to establish human answerability. Sa complexity ng AI, it's really hard to say where the individual humans got to get involved in. Okay, so there's this notion of accountability by design. Really make sure there's someone accountable at every step of the way. So I will now go very quickly to, oh, by the way, there's also this nice notion of you put in regulations proportionate to the risk. Kung low risk naman, wag na kayo masyadong, don't hamper too much of the development, of the experimentation, of the deployment. If it's minimal risk, leave it alone. But if it's really unacceptable risk, then prohibit it. So your intervention as a society would be according to the risk posed by the AI application, by the technology. Don't have a single sweeping bawal yan to everything, because then we will not be able to bring AI to the benefit of all. So let me just, I guess I'll have to do this in 5 minutes or even less. Challenge some of what we have talked about with this march towards technological singularity. Singularity means the machines take over, essentially, I mean in layman's term. The machines are so intelligent that they will decide on their own and we might not be in their world. Huh? We are creating machines that think and act like us and more until these machines decide or decided in the past tense, until they decide that they can just teach themselves. Think about that. Is that even possible? Can machines just teach themselves? So we are not part of that, sabi, ethical at every step of the way. Wala na nga tayo because the machines have decided hindi na niya kailangan mga tao. But maybe that's not possible. If you look at what happened in the landing on the moon in 1969, we are giving way to machines now. When it's Mars, wala nang tao. Rover na lang, right? And that was even in 1997. Tao na, machine na lang. And playing games against humans is an AI playground. It's a good basis for where AI was and is heading. So let's look at 1959. A computer was able to play good checkers. This was Arthur Samuel, IBM and Stanford. But 1997, tinalo na ni computer si Kasparov. Okay? At chess, being parang, we were so proud that chess is such a difficult game, machines are no way in our league, tinalo na tayo. And for something that was heavy on natural language processing, trivia and all that, the champions of Jeopardy lost to Watson, again IBM, in 2011. Okay? There you have to understand the words and your answer must be a question. Huh? And then you have to think fast and access all the info. Tinalo na in 2011. But the holy grail of games was Go. Of course, that it had more combinations than all the atoms in the universe, apparently. And Lee Sedol was the world champion in 2016. AlphaGo beat Lee Sedol in 2016. Now, I'm just using this because, not this one, but the next slide. Because from 2016, AlphaGo was reprogrammed. AlphaGo was taught by people. All these good players of Google Mind taught the machine how to play good Go so that it could beat Lee Sedol. But since they are people, they are limited by what they know, right? So what they did was to remove all people there and just let the machine create games every second for 24 hours a day, non-stop. Create a game, learn from it, create another game, learn from it. So the human teachers were no longer in the picture. This was in 2017. Machines have taken us out of the picture. And because the people were not there, the machine did not need to do a break. Walang health break, walang hunger break, walang sleep, just played and played. And within 42 days, plus or minus, this is just from memory, around 40 days, from nothing, it reached the level of AlphaGo. And within, I think, another few days, wala na. Unbeatable na siya. And it was able to come up with strategies that the best players of Go in the world did not know that there was such a strategy in Go to do those things. So you see now, from a point of view of games, that in fact, the machines are now harnessing the opportunity of learning from people not limited by human intelligence. Kasi tayo, may limit tayo sa IQ natin, di ba? Eh kung tayo magtuturo sa kanila, hanggang tayo lang ang kaya niya, right? But now they are moving us out, so they will, technically they can surpass us. In the case of Go, they've surpassed us. And they changed it. Tinanggal nila yung Go, ginawa nila for chess, Go, tama rin. Ano? This is the Alpha Zero. Alpha Zero. Alpha Go Zero kasi, tapos Alpha Zero na lang for chess, for Japanese chess and all that. The same mode worked. Okay? So if we trace, I think the way AI will be written in history, 2017 will be another big year. 2012, sabi ko, deep learning, di ba? 2017 is a special year. So we had the three ways of building machines: declarative, procedural, or machine learning. The fourth way will be the machines will create their own machines. This is the march towards singularity. As written by Kevin Warwick, he predicted it by around 2030, 5 years from now, that the machines, but he had been experimenting on himself. Naglalagay siya ng mga chips sa kanya. So he doesn't have to talk, type anything. They can just think, and the other machine will pick it up. Ganun yan, 1980s, 90s sa UK. And they couldn't put monkeys to work on tasks collaboratively with chips lang in their brain. Yeah, that was happening. It was probably not going to be ethical now, but at the time he got away with it. So you have technological singularity, I don't know, maybe 2030, 2040, within our lifetime. And this is my last slide. But in fact, if you look at the trend, you might have... you will not have humans versus machines, because the humans will have machines in us. Our glasses will have some processor that, as we see, we will have an aid there. You have this painter with a helper, with doctors with machines. O, di ba? O, meron pang girlfriend niya, human, tapos siya. And all these cyborgs. Okay, so I end there. So let's think about what happens about ethics and all that when that will be the world. Thank you.
Thank you, Doc Azcárraga, for sharing your expertise with us. Meeting influential figures like our speakers today can have a profound impact on aspiring individuals. With that in mind, let's delve into the opportunities for graduate studies in AI. And I'm pleased to introduce our next speaker, who is a distinguished academic and researcher. He serves as a professor of electrical and electronics engineering within the esteemed College of Engineering at the University of the Philippines, Diliman, where he also fulfills the role of Associate Dean for Research and leads the Engineering R&D for Technology Graduate Scholarship Program as its project leader. Additionally, he oversees the scalable high-performance computing facility and leads the eScience as a Service for Engineering team. Notably, Shark currently hosts and operates computing clusters for the College of Engineering for some of its constituent units and projects, and for its academic and research program in artificial intelligence. Let's extend a warm round of applause to Dr. Ruel M. Ocampo.
Thank you, and good morning, everyone. Admittedly, I had been struggling since this morning. Originally, the title of my talk would have been Opportunities for Graduate Studies, and I could easily, talk for hours about that in front of, let's say, a graduating class of undergrads. But looking at who's gathered here today, I realized that there's also this other side where we should also explore, or perhaps we can consider exploring what opportunities are afforded to us as a country because of graduate studies. So it's not just opportunities for those graduating or finishing the undergrad, or about to pursue even out of professional work, but also if we take the logical complement, what opportunities are lost if we don't pay attention to grad study? So in anything, it's very useful to start with why. Why is grad study important? And if you haven't seen this talk by Simon Sinek, I highly recommend it. It's a very good talk. I think it's a TEDx talk. As a spoiler, so sagutin ko na bakit, no? And I think most of us will agree, all of us will probably agree, that we are after sustainable development. Lahat ng mga proposals ngayon, laging SDG, alignment, etc. So, wala naman sigurong question dyan. And one of the elements, it's not the only goal, but one of the key elements is sustainable industrialization, right? So, we can picture a future where we're industrialized in a sustainable way. But I would also like to use the term sustainable not only to pertain to protecting the environment or making sure that resources are there, but sustainable in the sense that we have the capacity to maintain or improve. And I would argue that if we're going to think about industrialization, if we're going to think about anything that we do, it has to be sustainable. We have to have that ability to keep it going. And not only do we need to do that, we also have to scale. So, nung kanina ko pa iniisip, and I was looking at the presentations, parang iniisip ko, paano i-contextualize doon sa successes nitong project, doon sa accomplishments nung teams. And if I were to distill the answer to that, I would say, paano natin i-sustain yung mga ganitong efforts? Paano natin to scale? The former director of ASTI, si Professor Solis, I don't know kung naabutan nyo, meron siyang half joke na sinasabi, my goal as ASTI director is to make myself irrelevant. Medyo malalim yun, ano? Pero ang point niya is to empower and capacitate everyone such that it no longer just depends on me. So, kumbaga, paano natin i-clone? Paano natin i-clone si Doc Joe? No? It's a scary thought. Almost a scary... Joke lang. Okay, so industrialization, scalable, sustainable industrialization. Where are we? If that's the goal, if that's what grad studies is supposed to help achieve, where are we? Unfortunately, nandun tayo sa ilalim. If we look at the two indicators defined by the UN, research intensity, this has to do with investment in R&D. The other one is researcher density, which numerically is pegged at the number of full-time equivalent researchers per million population. Indonesia has twice ours in terms of density. Vietnam 7 times. No wonder, pagdating sa research sa AI, pagdating sa decision, for example, ng NVIDIA kung saan sila lulugar, Vietnam. And Vietnam isn't even happy doon sa, sa dami ng PhD holders, for example. Tingin nila kulang pa for the kind of industries that they want to promote. Of course, wag na natin pag-usapan yung Singapore, no? Ang layo talaga. Right? Now, it would be reasonable to assume that the bedrock of the ability to generate researchers, yung mag-contribute dun sa figure na yon, yung density, kung ilan yung full-time equivalent researchers per million population, would depend on the state of higher education, right? And if we're going to train researchers, then ideally then yung faculty members would have been thoroughly and intensively trained in R&D. And that happens at the PhD level. This is not to say that if you don't have a PhD, you can't do R&D. Merong mga hindi pa nga gumraduate ng BS, nakapag-publish na, no? Pero yung systematic and intensive training really happens at the PhD level. So, logical na yung faculty members who would be training the next generation would have been professionally trained, intensively trained. Based on CHED's data, if you were to array all of the PhD holders sa engineering, sa HEIs, higher education institutions offering engineering, more than half would be concentrated in less than 10% of all of these institutions. That's not good. These would be the usual suspects: UP, LaSalle, Mapua, MSU. It might be a source of pride for these institutions, but I'm not really proud of it. I think it's bad for the country that most of the PhDs are in this few institutions. We cannot scale if it's like that. So, educational system, not yet ready to generate or scale and sustain industrial growth based on researcher density production. Now, I mentioned PhDs, no? And if you're considering to do a PhD, dapat ba pumunta ako sa academe to correct that situation? Well, we should, kasi yun ang mag-generate ng researchers, yun ang magte-train ng researchers, pero hindi dapat yun lang ang goal. Kasi, di ba, merong misconception na, you're going to get a PhD, that means you're going to the academe. In North America, today, majority of new PhDs in AI are going to industry. So this also tells us something. What fuels industrial growth, especially in AI, no? This tells us something. It's not really just the academe. In fact, kanina tinitingnan ko yung paper na finlash ni Doc RD, yung I think 6 out of 8 authors were from Google, right? And that's not the academe, right? Some professors from the University of California, in fact, did a study. Ano ba yung nag-contribute sa growth ng Silicon Valley? It's a good place and case study na aralin, di ba? Silicon Valley. We all know what Silicon Valley is. And they found that the growth of Silicon Valley was fueled by 2 things, parang dalawang model. Yung isa, sa biotech, it was really tech transfer, patents, etc. Pero sa electronics and IT, hindi yon. Hindi tech transfer ang nagpalaki ng electronics and IT industry sa Silicon Valley. It was the flow of people. It wasn't the transfer of technology, it was the transfer of people. So, and in fact, in this study it says, the most effective knowledge transfer mechanism is by the transfer of people. Okay? So, something to think about. Baka hindi popular view ito, pero lahat naman tayo ay researchers or policymakers. So critical analysis is what we need, right? Hindi na siguro ako makakuha ng funding sa DOST if I say that tech transfer is people transfer. That's what they found. No? And also in this context, yung main role ng university is really to produce people. Of course, knowledge and people. Ang gusto ko lang sana i-point out, baka kasi magkaroon ng expectation in the long run na ang universities and even RDIs, ang main job is to produce products for commercialization. I think that if that becomes a singular thinking, that's a bit short-sighted. We keep talking about low-hanging fruit and things like that. Personally, I am all for seizing all of these opportunities. Kung may mako-commercialize, by all means. If it solves a societal problem or an industrial problem, yes. If you get rich in the process, even more so, hindi tayo galit sa pera. But for that to be the main motivation and sometimes the barrier for other worthwhile endeavors, yun ang medyo kailangan bantayan. So why is it so important to think about the transfer of people specifically into industry, which is what is happening in North America? I was asking Doc Joe kanina, parang meron bang private sector na guests right now? And sabi niya, wala. And I don't fault the project for that. Kasi there's a reason for that, right? Madalas sa mga proposals, hanapan tayo ng private sector partner, doon dapat ita-transfer yung technology, tapos mako-commercialize. No? That model might work in more advanced economies where the private sector is really ready for that sort of thing, right? But when you look at the private sector, you actually have to look at two aspects. Number one is their readiness to assimilate new knowledge, external knowledge, and the other one is their ability actually to create new knowledge. So yung usually in-expect natin sa universities, dapat merong ganon sa private sector. Yung private sector should be able to create its own products, its own knowledge, and therefore fuel scalable and sustainable industrialization in partnership with universities and the government and RDIs. Ano yung proof natin ito? Wala akong proof ng causality, but if you look at, for example, the top companies, the companies with the most number of PhD holders, just as a metric, no? Google, Intel, Apple, Microsoft, Facebook, Amazon, IBM. Hindi ba parang yan yung mga nire-recognize naman natin na tech companies, no? So if we can't really prove causality now, at least medyo obvious naman yung collaboration, yung correlation, I'm sure. Correlation. And if you further dissect, eto bang dami ng PhD ng Google, anong percentage yung graduate degree holders sila? More than 44% of all of their employees are graduate degree holders. This should tell us something. This should also tell us bakit dun sa paper kanina na finlash ni Doc Arnie, 6 out of 8 authors were from Google. No? I've also seen their publications in SIGCOM, for example, yung top conference sa networking. And pag nag-umpisa ba naman yung paper with, we tested this new protocol on 100 million browsers running Chrome, eh, paano ko pa magko-compete sa ganung klaseng R&D, right? Meron ba tayong local success stories. I'm not really that well versed with how it is with AI now, but this is something that we uncovered fairly recently. Triple E in UP Diliman has had a partnership, a long-running partnership with Analog Devices, and the people involved asked Analog, ano ba yung value ng partnership namin sa inyo? Can you tell us? So Analog actually prepared this slide. So what Triple E has been supplying Analog Devices are people. Wala kaming patents na binibigay sa kanila or anything or designs. Puro tao lang na trained sa design. Right? If you look at the electronic sector, design is not what they want exactly. Design is as a whole, as yung majority, di ba? Ano tayo packaging, assembly, test. Right? And that's an export winner. Kumikita yan for the country. Pero Analog decided, okay, design, give us engineers who know design. Out of all of this, one thing struck me. Yung value sa kanila, nung products na na-create ng mga tao na lumipat sa kanila, na nakuha nila, in cumulative revenue in excess of $1 billion. It's not even pesos. It's in excess of $1 billion. And yung mga engineers na Analog Devices here in the Philippines started to get recognized worldwide kasi biglang nagpa-publish dun sa internal conference nila, etc. Biglang may patents, biglang may mga ganon. No? So this tells us that if we produce people and these people also go into industry, if we can also take care of higher education, then this should produce value as well. This would perhaps contribute towards scalable and sustainable industrialization that happens within the private sector. How about AI? It's promising. This, from the UNESCO Science Report, they measured the growth in publication. So this doesn't say anything about the absolute number, but in terms of growth, labang pa tayo sa Russian Federation. This is growth, of course. From 1 to 2, it's 100%. I don't know the actual base figure, but it's promising, right? And this is 2016 to 2019. I'm sure mas marami pa ngayon. Di ba? I'm sure mas malaki pa yung growth ngayon. Okay, if you do grad studies for anyone who's interested, or if we decide to invest in grad studies, anong klaseng research training ang pwede nating mapagdaanan? Anong klaseng research ba ang in-expect from the academe? Some of it might be relevant. A smart advisor would look for relevant and impactful research because that's also where partnerships and funding can come from. But let me tell you that perhaps the most enlightening conversation I had with my advisor went something like this. No? Roel, after you do your PhD, your dissertation will be sitting in the Senate Library, yung do sa archives, gathering dust, and probably no one would have read it except you, me, and your exam panel, and no one else. And years from now, you will read your dissertation and you will cringe at the things that you wrote, which is true. No? Pag binabasa ko. Minsan may excerpts do sa dissertation ko, ginagamit kong example ng what not to do when you write. No? Bakit ganon? Kasi it's training. No? For those who are parang nakakatakot mag-masters and mag-PhD, Huwag nyo lang tanungin si Elmer na baka sabihin niya, huwag kayo kay Ocampo, no? So wag siya yung tanungin nyo. But it's training. Practice lang yan. No? If you're lucky, you might get a topic that's really, really good. Just like this example. So Darwin Bautista, master student sa AI, Master of Engineering student, nag-publish ng paper tungkol sa parsec. Parsec eventually got cited as state-of-the-art dun sa blog ng NVIDIA. And the parsec library is now used in ISAC, which runs in the International Space Station. Okay, so siguro may konting side, hindi lahat ng research sa academe merong immediately identified product or commercialization potential. But it can be like this, na nasa International Space Station. For most of us, going through grad school, baka wala. Pero practice lang yan eh. Just like when you write a term paper sa English 10, hindi naman ina-expect na Pulitzer Prize winning yung term paper. Practice yan. The career starts when you go out there with your grad degree. If you're also lucky, then you might end up, doing something that's also really relevant in terms of solving environmental concerns and so on and so forth. This is from Prosnaval's project and effort with Laura David and others. Okay, so sana yung iba na hindi pa nag-grad study, kung medyo convinced, saan kayo pwede mag-grad study? Hindi to biased, kasi ang ano ko lang is UP Diliman, yun lang kasi yung medyo meron akong details, but this might offer a sampling of what's out there. No? There's a Master of Engineering program in AI in UP Diliman. Perhaps the most attractive for practicing professionals would be the core courses. Parang yan yung dessert, although main course siya, no? Pero parang yan yung masarap isa-isahin na ganun. No? So you take courses in classical machine learning and advanced machine learning, even ML Ops. No? Kasi importante yung underlying infrastructure, right? Importante yung workflow and so on and so forth. I won't go into that much detail, but if there are questions, I'd be happy to refer you to those interested to the people in the program. There's also a PhD program. You can enter the PhD program even without a master's. Okay? Parang 4 years yung kung wala kang master's, but let me tell you, yung 4th year puro research. So what if nai-atras mo what if you started your dissertation early? I've done that before with an advisee. First meeting namin, pinag-usapan kaagad namin ano yung magiging flow ng dissertation niya. Chapters ang pinag-usapan namin. When you get to this chapter, maybe you'll need to explore the economic implications. So at this point, kuha ka ng elective sa School of Economics, something like that. Natapos siya 3 years. PhD, wala siyang master's degree. Doable yon. Okay? We can also provide a bit of support dun sa computational needs while you go through the program. Medyo bata pa itong infrastructure na ito. Started around 2022, I think. Pero medyo dumadami na paunti-unti yung mga machines, no? But this stuff is expensive. I would like to emphasize to our partners in government, in the UST, mahal po talaga ang R&D sa AI. I do fully appreciate the effort to democratize. I think that's really great, no? Parang not everyone can afford this stuff. Siguro ang kailangan lang natin timplahin, kailangan din matuto, ma-scale natin, ma-sustain natin, ma-distribute natin yung know-how doon sa infrastructure. So we also need to think about that, no? Okay makagamit ng infrastructure that's already there, that's in the cloud. But what about the challenge of training people in setting up these things and maintaining these things? Medyo mahirap siyang, the care and feeding of high-performance computing is also a challenging thing. There are also a number of faculty members from different fields. The really nice thing about AI is you can find application across several disciplines. So exciting siya. And meron mga students who don't come from a computer science or electrical engineering background. May isa ako na-meet na economics nga yung undergrad niya eh. Pero nasa AI program ngayon. Meron lang ako isang slide tungkol sa ERDT, pero supposedly ERDT project leader ako. Pero the only thing I want to point out is you can also be a scholar ng bayan while studying. So ERDT provides support for tuition, stipend, and so on. Ang isang gusto ko lang i-highlight, because these things, pwede naman ipadala yung brochure if there are people interested. Merong opportunity for sandwich program, meaning if your advisor identifies a lab abroad or has a collaborator abroad, pwede kayo ipadala doon for, I think, between 6 to 12 months and spend time in a lab abroad. And that's a very good opportunity. Working with foreign collaborators, without the pressure na parang nandun ka for the full 4 years and hindi mo alam kung ano yung harapin dun sa university abroad. No? So it's the next best thing. Plus, you develop contacts in those laboratories abroad. So, yun lang po, parang I hope this was not just about offering opportunities for those about to or considering or maybe hindi pa na-consider dati na mag-grad studies, but also maging clear sa atin gaano ka-importante yung grad study para mag-advance yung hindi lang yung technology na ganito, which is really high-tech, AI, but also yung impact ng grad study para sa sustainable and scalable development, particularly sa private sector. Thank you.
Thank you so much, Dr. Ocampo, for your informative presentation on the vast opportunities and prospects for graduate studies in AI. We also extend our sincerest gratitude to our exceptional speakers for inspiring us with your invaluable insights and expertise. Your enlightening presentations have laid the foundation for a productive discussion for our plenary question and answer.
We now encourage participants to take part in a plenary question and answer session, during which our speakers will respond to your inquiries and promote a vibrant exchange of ideas.
Yes, we will be catering a few questions from our guests and participants. If you do have questions, you may raise your hand. And upon asking, you may spell your name, your organization or affiliation, and you can direct your question directly to the intended speaker. Yes po. So do we have any questions from our guests and participants? All right, we have a question right here.
Hello, good morning. I'm Nathan from the DOS 11. I would like to ask Dr. Azcaraga. Last year, I was able to meet with a company that provides an LLM service for the Supreme Court of the Philippines. So they are planning to create this model in order to what they call that, streamline the jurisprudence. So considering its impact to the judiciary, of course, we all know that in developing large language models, there are safety protocols in check, such as what they call that, the development of a training, testing, and validating a validation data set. And we also have the confusion matrix and other error indicators like RMSE, MAE, MAPE, so on and so forth. So what are your thoughts about this development of the LLM for AI for the judiciary? Thank you very much.
Yeah, I am also familiar with, I have a colleague who I think worked on it also partially, pero private company. At the end, whatever your validation results will tell you, whether it's 99% or 83%, etc., that will just be there. Yes. The final use of it during your deployment will have to be vetted by experts, and partly because it's law, right? And also because the field is so context specific, how should I say? There's a lot of nuances, right, in law and how it's used, how it's useful, how it's applicable, that your LLM might miss it, even if you train it specifically for that. When I talked to my colleague who worked on that, I really had a feeling that if it were law, it should have been the more traditional, traditional, you say, because it's quite sensitive. But certainly in that entire support for legal research and all that, there is space for LLM. But please reserve a lot of portion in the decision making that is still left with human experts.
Thank you very much.
Thank you, Sir Nathan from the USC Region 11, and thank you, Doc Ascaraga, for answering the question.
All right, do we have any more questions or inquiries? Ma'am?
Okay, good afternoon, everyone. So I guess this question is still addressed to Dr. Ascaraga. So with regards to his presentation just a while ago, I think all of us will agree that creative AI is really amazing. So it has been prevalent in design, art, and fashion, as you presented earlier. The question is, how do you see its growing presence shape the future of the creative industry? And do you think it enhances or limits human creativity?
When I started working with students on generative AI for literature, for poetry, for industrial design, I thought, really, personally, I thought that it was the best thing that could happen, because it's now entering a field that we thought was reserved to humans, right? And that I thought the world welcomed it. I was so surprised that those in the creative industry were so mad at it that they felt, hindi lang, there's the IP, because sometimes some of these AI, they sort of like cut and splice and resurface something that looks so similar to an original work. That's an issue. That's really an issue already, and that has to be corrected. But even in machines pretending to be creative is abhorring to a lot of people. And I don't know if that will be like the sonnet story, that over time we will get used to it. But you know that there are art pieces that are very expensive, which were really just digital art. They were created by machines and they sold for so much. So I don't know how the world will welcome it in the next few years. But personally, I feel that it has some space, even in schools, to work with AI to give you ideas. And then once you've seen what are possible, parang ano lang yan eh, you read poems of other people before you write your own. listen to songs of other people before you write your own, painting and all that. Ganon din ko lang siya nakikita. But I will not be surprised if many people will go vehemently against it because it's like well, you don't cross that line because that's too human to give way to machines.
Sorry. Baka nagugutom na yung iba, but just very quick. I'm just wondering, do you already have policy in place in your institution as to, like, how do you validate that it's an AI-generated artwork maybe, or?
No, it's not validated. You are responsible in disclosing that it was that you use AI in so even not just for creative work, for students, when I teach machine learning, I ask them to use AI first and then build on it. But they have to declare which parts came from a chatbot or an AI tool or whatever, and which parts did they change, and finally what their final product was. I think, this is again personal, I think we have to embrace it and then make it part of our learning in school so that children will get used, students will get used to mixing work from machines and algorithms with their own creativity and their own inputs. Because that is the world that they will enter after our university. So let's just put those things and then the habits in place, keep things ethical, but don't push it out and don't ease it out of the learning process.
Thank you again, Dr. Escaraga, and thank you, ma'am, an academic representative from University of Southeastern Philippines. For now, we will be catering one last question. We have another question.
Hello, good morning, everyone. I am Vera Kim Tekin from the University of Southeastern Philippines, and my question is for the Philippine SkAI Artificial Intelligence Program. I would like to know if there are existing models that automatically identify and classify solid waste in the Philippine Sea, and can we also freely access the Copernicus images?
Yeah, thank you for the question. So, for solid waste, we don't have it, but the models. But if we have the data, we can actually train the models to do that.
So we can, if there is, sir, can we freely access it, or
Sure.
through the SkAI?
Through the portal.
Yes, sir.
Yes. So once we roll it out, we will do a vetted kind of how do you call it, use. Like for example, maybe from USEP, you apply and then i-vet lang namin para sure lang kami na hindi kami flood masyado ng maraming tao. Okay, tapos pwedeng ma-access yung port. Yes.
Okay. Thank you, sir.
Thank you.
Thank you, Dr. Rubico, and ma'am, a representative from University of Southeastern Philippines. Now, if you have any further questions, please write them on the evaluation form. We will forward them to our resource speakers.
Yes, sir. Yes, sir. I see. We have one last question.
Anyone can answer this. I have a question that, using the AI, we are, parang ginagamit na natin for fake news. How can we prevent this, making the fake news through AI?
I'm sure the other universities are working on it. We have fake news detectors that they can tell from the way it's written that it seems fake. These are master students. I've encountered some of those, but the other universities might be saying that. But the point that I wanted more to talk about, might not directly answer your question, is we will be the world that we will be facing the coming years will be more bombarded with fake, not just news, fake photos, fake videos, fake stories. And so I thought that we should not even just rely on detectors and algorithms to detect them. I think we should teach our children to be more analytical. When things are so too good to be true and just seems too you'll have those little red flags. We have to teach that, and my students should I think get used to those and use their analytical mind to verify and not just take every story they get, every news they receive, every picture they get to be true. When that has to be part of our habits coming into this world where AI and malicious AI has entered mainstream. Yeah, thanks.
Thank you.
Thank you, Doc Ascaraga, for answering the question, and thank you, sir, from the multimedia team. Again, if you have any further questions, please write them on the evaluation form. We will forward them to our resource speakers and get back to you once we receive their responses.
All right, Rans, I think that sums up our question and answer. We're pleased to move on to the awarding of certificates. As a token of our gratitude, we are honored to present certificates of appreciation acknowledging the expertise and participation of our speakers.
We kindly request the presence of Dr. Rubrico on stage for the awarding of certificates of appreciation. Please allow me to read the citation. Certificate of Appreciation is hereby awarded to Dr. Franz A. De Leon for imparting invaluable insights as a resource speaker during the 3rd SkAI-Pinas Program-Wide Congress, given this 27th day of February 2025 in Davao City. Signed by Dr. Jose Ildefonso U. Rubrico, SkAI-Pinas Program and ALAM LSI Project Leader.
May we request Dr. Rubrico and Dr. De Leon to please remain on stage for the awarding of certificates to their resource speaker. In appreciation of their invaluable contributions as today's resource speakers, we are honored to present certificates of appreciation for enriching today's program.
The citation under certificates reads as follows. Certificate of Appreciation is hereby awarded to Ariel C. Blanco, PhD, for imparting invaluable insights as a resource speaker during the 3rd SkAI-Pinas Program-Wide Congress, given this 27th day of February 2025 in Davao City. Signed by Dr. Jose Ildefonso U. Rubrico, SkAI-Pinas Program and ALAM LSI Project Leader, and Dr. Franz A. De Leon, the Director of the USDST.
The same certificate of appreciation with the same citation is presented to Dr. Reynabel C. Reyes.
Same certificate of appreciation is also given to Dr. Arnulfo P. Ascaraga.
Another certificate of appreciation with the same citation is presented to Dr. Ruel M. Ocampo.
May I request Dr. Rubrico and Dr. De Leon to please remain on stage for the awarding of certificates and token appreciation to Prashir.
Please allow me to read the inscription. Certificate of Appreciation is hereby awarded to Ms. Mayros B. Parinas and Engineer Bianca Marie B. Domingo for their invaluable contributions throughout the program project implementation of the 3rd SkAI-Pinas Program-Wide Congress, given this 27th day of February 2025 in Davao City. Signed, Dr. Jose Ildefonso U. Rubrico, SkAI-Pinas Program and Alam LSI Project Leader. Signed, Dr. Franz A. De Leon, Director.
As our key partner, funding, and monitoring agency for SkAI-Pinas program, we are honored to present these certificates. Another certificate of appreciation is hereby awarded to Ms. Joanna G.C. Huco for imparting invaluable insights during the 3rd SkAI-Pinas Program-Wide Congress, given this 27th day of February 2025 in Davao City. Signed by Dr. Jose Ildefonso U. Rubrico, SkAI-Pinas Program and Alam LSI Project Leader, and Dr. Franz A. De Leon, Director of the USCST.
We also have another certificate of appreciation with the same citation is hereby awarded to Assistant Secretary Rodolfo G. Calzado Jr. and Engineer Mylene B. Jerez.
Same certificate of appreciation is hereby awarded to Engineer Alvin E. Riotamar. Lastly, we invite Dr. De Leon to please stay on stage to honor the next recipient with a certificate of appreciation for his exceptional work in spearheading this program.
Let me read the citation. Certificate of Appreciation is hereby awarded to Dr. Jose Ildefonso U. Rubrico for spearheading the 3rd SkAI-Pinas Program-Wide Congress given this 27th day of February 2025 in Davao City. Signed, Dr. Franz A. De Leon. Thank you very much, Dr. Rubrico and Dr. De Leon.
To officially conclude our program, I am honored to introduce our respected guest from the USCST who has graciously joined us today. She is the Chief Science Research Specialist of the Computer Software Division at the USCST, where she leads and oversees pioneering research and development in artificial intelligence, next-generation computing paradigms, secure decentralized systems, and innovative software solutions. She holds a Bachelor of Science in Mathematics with a double major in Computer Science from the University of Santo Tomas, and a Master of Technology Management from the University of the Philippines, Diliman. With a strategic vision of software-driven innovation, her expertise and leadership have been instrumental in advancing AI research, system development, and cutting-edge software applications. Under her guidance, the Computer Software Division strengthens partnerships with the government, academe, and industry, delivering impactful software solutions and development consultancies. Driven by her passion for bridging emerging technologies with real-world applications, she remains dedicated to fostering innovation and strengthening the Philippines' digital landscape. Please welcome on stage Ms. Joanna G.C. Huco. A warm round of applause, please.
Magandang buhay. Dugtungan ko lang po yung sinabi kanina ni Doc Roel Ocampo. Hindi naman po tayo galit sa pera, lalong hindi naman po tayo galit sa pagkain. So, give me around 6 to 7 minutes to officially close our plenary session this morning. As we conclude the third Philippine SkAI Artificial Intelligence Program-wide Congress, I extend my sincerest gratitude to our speakers, participants, and partners for contributing your insights, experiences, and enthusiasm throughout this event. Over the past 3 years, our division has worked closely with our stakeholders. We've seen firsthand the hurdles that research teams in the government face, such as limited computing infrastructure, the complexity of data pre-processing, and the steep learning curve of developing and deploying AI models in real-world settings. Our job is to address those pain points by designing and maintaining reliable software systems that fit each group's unique needs. By continually refining AI models, workflows, and user interfaces, our goal is to empower more stakeholders to adopt AI, no matter the size of their teams or the complexity of their challenges. One of our key initiatives is the DIMER, or the Democratized Intelligent Model Exchange Repository. DIMER offers researchers access to a growing library of pre-trained AI models, thanks to our AI engineers and systems engineers who handle everything from back-end architecture to performance optimization. DIMER is evolving into a valuable resource for AI development and adoption. I'd like to highlight how partnerships are central to everything we do. In developing these solutions, we engage not just with our internal teams at DOST-ASTI, both QC and Davao team, but also with government agencies, academic institutions, and industry partners. We talk to them about what works, what doesn't, and where they need additional support. This continuous feedback loop informs how we refine the usability, model performance, and integration pathways, ensuring that every update directly benefits our end users. We strive to maintain a transparent, agile process, whether it's ensuring quality standards for our internal code milestones or creating clear targets for our upcoming pilot deployments. Our approach emphasizes iterative development. We deliver functional prototypes quickly, gather user feedback early, and then we fine-tune the product. In this way, our collaboration can see tangible progress and help shape the final outcome. Most importantly, we pledge to work hand in hand with our partners to ensure that every solution we develop directly addresses the nation's most pressing needs. Looking ahead, we aim to expand the program's reach beyond our existing partners. We envision more end users, either small tech startups or government agencies in the regions, coming on board to leverage the AI models we've developed to tackle very localized, real-world problems. We also plan to host training sessions to help our stakeholders navigate the platform and adopt the AI models we develop. In doing so, we hope to foster a supportive environment where AI becomes second nature for local teams who can develop, adapt, and improve solutions on their own. The Computer Software Division stands ready to provide guidance, expertise, and steadfast commitment to excellence. We believe that by pooling our talents, we can build a strong, inclusive AI ecosystem that truly benefits Filipinos. As we move forward in today's Congress, I encourage you to think about the challenges and opportunities in your respective areas. If you see a way for our division to assist, either through Dimer or a broader collaboration, please reach out. The more we align our efforts, the better we can serve the communities and ultimately advance AI development in the Philippines. Thank you once again for being here and for sharing your time. Let's continue building a vibrant, inclusive ecosystem that harnesses the transformative potential of AI for every Filipino. Sa tulong ng agham, teknolohiya at inobasyon, sama-sama nating isulong ang pagbabago tungo sa matatag at maunlad na Pilipinas. Maraming salamat at mabuhay po tayong lahat.
Thank you, Ma'am Joanna. Your tireless efforts, unrelenting support, and steadfast commitment for the project are greatly appreciated.
Yes, but before we forget, with regards to the plenary question and answer, for additional questions, there will be a roundtable discussion later with Dr. Rubrico and Dr. De Leon. After your lunch, you may proceed to the Garcinia Function Hall right across this hall if you would like to attend.
This concludes the Philippine Sky Artificial Intelligence 3rd Program-Wide Congress. We extend sincere gratitude to all participants for their valued time and engagement. Thank you very much for joining us.
Yes, we hope you found our sessions informative and engaging, equipping you with fresh insights, and may the expertise shared today illuminate your future endeavors in AI.
Let us persist in fostering innovation to drive progress in research and development, and may innovation remain our guiding force with the hope that it will continue to lead us in our pursuit of a more prosperous future.
It's been an honor hosting.
This has been Renz and Jonah. Once more with gratitude.
Madaya ug maayong buntag. Daghang salamat. Before we proceed with the lunch, to commemorate today's event, we invite everyone for a group photo session along with our invited guests. But for convenience, you may stay at your table and our photographer will take the photo angle from the stage.